Hi everyone, I'm Miss Felicia from OVERMUGGED. I'll be teaching you Sec 2 Science for today. Okay, so for the online attendees, if you did not collect the revision kits, can you scan this QR code right now to download the lesson material for today? Okay, so just a little bit self-introduction about myself in case maybe some of y'all never seen me before or never heard of me. So that's me. I'm Miss So I specialize mainly teaching in IP science. But today we are just doing together like be it Express or IP. We are like, having just an overall Sec 2 revision session. Yep. So for me, I've been teaching from Sec 1 to Sec 4 sciences. So for lower Sec, I teach lower Sec IP science. And the students that I teach mainly are like from NYGH or like RGS. But I also do teach like students of other schools also. Yeah, then for upper sec, I mainly teach chemistry and physics. Yeah, so before I joined OVERMUGGED, these are my teaching experience. So previously, I was actually at the Learning Lab for 7 years. And then even earlier, I was also teaching at another tuition center called Wisland. And I was also a MOE teacher at various secondary schools. Yeah, so here's my track record of my students for the past few years. So just to share a little bit about myself. So I really like board games. Yeah, that in my house I actually collect a lot of board games. I even buy like board games and then buy expansion pack kind and spend like hundreds over of dollars. Then after that there is this like saying that people say that like must be, is it like when I was like a student time I studied too hard, is it like I didn't like have enough time to play. That's why now as an adult I like to play so much. Yeah, so besides board game I also like buy like Nintendo Switch to play. Yeah, so it's like I like board games so much that I even like bring games into my lesson. So some of y'all who are like my regular students here, y'all know like you play like wet heads during like the topic of like chemical formula. Yeah, so the wet head is like a machine where it will leak water only for one stick. So out of 8, only one will leak water. So it's more like a punishment for my naughty student who, why you never study? Yeah, so if you never study, then yeah, you have to, based on your luck, you pull one stick. And then you might get wet if you pull the unlucky stick. Yeah, but I don't put that much water lah. Yep, so that's the wet haze. Yep. Then I also like played card games also, like the ion card game with my upper sec. Yeah, so that is actually the making of like the chemical formula. Yep. And then yeah, so besides board game, for me, I also value in happy learners. Yeah, so for my students who do well, so yay, some of you are t-shirt. Yeah. Yeah, so like for my this class, which I'm very proud of, the whole class got like A1 for the recent WA3. Yeah, so this is my Sec 2 NYGH class. Yeah, so not even A2, the whole class, like all 40 students, like A1. Yeah, so then since it's like such a good result, of course, must hold a party to celebrate, right? That's why I asked them like what food they want. Then they chose Wingstop. In the end, I ordered like $100 over of like Wingstop. It was $100 over, yeah. So it's like, wow, like, but it's okay, because it's worth it, because you all did so well. Yeah. Then yeah, so different class, different rewards. So some classes I gave like soft toy. I think some of my students, yeah, every round they can keep collecting. So the WA1 I give, WA2 I also give, WA3 I also give, EOY I will also give. Because some of them managed to collect like quite a few already. Yep. Then I will also like sometimes order like bubble tea. Yeah, so OVERMUGGED very like to do this bubble tea tower. Yeah. Then sometimes I order like pizza. Yeah. So for me it's like I will reward you like when you do well. So this is for my classes. Yep. Then sometimes also I will buy like acai affair from my downstairs. So if you are an OVERMUGGED student, you will be entitled to student discount for acai affair downstairs actually. Yeah, but that's for OVERMUGGED regular students. Yeah. So then for me, I find that it's important for students to be interested in the subject, because if they are not interested in the subject, then how to do well, right? Yeah, so usually I will also include hands-on experiments, yeah, in the lesson, yeah, hands-on activity. Yeah, so these are some of the experiments that we did during lesson time. Yeah. So yeah, then done. Okay, so I think more or less that's all about myself and my classes. So let me share with you a little bit about OVERMUGGED in case like you never hear of this brand before the event today. Yeah, so OVERMUGGED is actually an established tuition brand where we actually have 7 branches across Singapore. So these are all the 7 branches that we have. And under us, we actually have 1,000 over students across the 7 branches. Yeah, and you can actually find us at like various social media platform. Yeah, so we are also on like TikTok, Telegram channels, IG, YouTube. Yeah, so if you are into podcasts, we actually have weekly podcasts also. Yeah, on like telling you on tips on like how to do well for the various subjects. Yep, then yeah, so this is so far OVERMUGGED's achievement so far. So 70% of OVERMUGGED students have been achieving like at least A1 or A2. Yeah, or if it's like 3.6 or 4.0. And rest assured that you are in good hands because all our tutors here are all at least university graduates. Yep, so some teachers are from MOE, then like I myself, I'm like from Learning Lab. Yeah, so we all have rich teaching experience to guide you through. Then don't know whether are you all aware, like last year Overmark was featured in quite a lot of like newspaper articles. Yep, so we were featured in like this like Straits Times, you can see right, Straits Times. This is like Today newspaper. Yeah, we are also featured in various other languages newspaper. Like we were featured in like an Indian newspaper, in a Chinese newspaper also. Yeah, because Overmark is actually one of the first center where we actually organize large scale mock exams. Yeah, because you know MOE nowadays they remove like mid-year exams. So some students they will find that like they are not confident when it comes to end of year exam, because like end of year exam is like the very first like exam setting where you test on all chapters. So it's like if you have a mock exam, it's like in a way you can like force themselves to like like get themselves to, hey, I must study before I attend the mock exam. So it's like make students to revise their work, and in a way they can also know their performance, because based on the result from their mock exam they can know that, okay, like how much more I need to do for the certain subjects. Yeah, so that is yeah, our mock exam. And if you are our students, I think you know some of you who are my students, you will be able to get access to all these materials. Like we have like the curated notes that's especially designed with answering techniques to be able to help you to answer like open-ended questions. And then there are like study tips on like how to remember certain concepts. Yeah, then we'll revise for like WA's exam. Then we for upper sec there will be actually practical notes, and then we also have cheat sheets. Like all my students, they usually have this like the laminated periodic table, like front back. There's like a lot of information that they can use it. Yeah. So yeah, like that. Yeah. Then yeah. So that's all for Overmark. So without further ado. So for the lesson today, we would be going through these three topics: thermal energy, chemical changes, and transport system in living things. So after I recap with you the three topics notes, sorry, I know that your end of year exam cover way more topics, but I can't possibly cover every single chapter, because if I cover every single chapter, I can only do like maybe 5 minutes per topic or 10 minutes. Then that is like a bit not useful, right? Because if I only go through 10 minutes, like go through what? Yeah, so I rather I go through in depth, then we only pick on three topics lor. Yep, but the mock exam, no worries. At the back of this booklet, there is actually the mock exam. It will cover all chapters that you need for your Sec 2 end of year exam. Yeah, so for the mock exam, later I won't be giving you time to do. I will be just going through the answer, so it will be a review. So if you haven't finished your mock exam paper at the back of the booklet, can you try your best to multitask and try to finish as soon as you can? Because later I will be going through the answer already. Then while I'm going through the mock exam paper, if you can't finish copying in time, no worries. At the end of the session today, I will be giving you the answer key. So later you can like scan the QR code. I'll give you a QR code. You scan the answer key, then you can go home slowly write down the correction in case like you write slowly. Yep. Yeah, then yep, let's begin with lesson now. So just to confirm, for those online, all of you have the lesson material for today, right? Which is the revision kit. Okay, so yep, so let's start now. Sorry, can you shift in since the lesson is starting already? Yep. So sorry, can you just shift in? Yeah, shift in, shift. So if anyone is coming, then you can just direct them to sit at that seat over there lah. Yep. Okay, so for today, let's start off with thermal energy first. Can you flip your notes to page 7? Ah yeah, hi. How many of you? Yeah, Sec 2. Only yourself, is it? Oh, then there's one seat all the way at the end. But you have to squeeze through. I don't know how you squeeze, yeah, but you try find your way to walk through. All the way there. All the way there. There's only one seat left. Yeah, so you have to go there. Okay, so for this topic on thermal energy, it would be mainly covering on three components: conduction, convection, and radiation. So now I'll be covering with you one by one, starting off with the first part here on conduction. Okay, so so how do you differentiate between like the three processes, like conduction, convection, or radiation? The way to recognize would be, one is that conduction usually happens when the heat source is in contact with the object. So like for example, if I have a Bunsen burner, then if I put my rod into the Bunsen burner, that is called conduction. Or maybe the heat from my hand, and then I hold this rod. I want to conduct the heat from my hand to this metal rod. That's also called conduction. So conduction is usually things that are in contact. As well as you need to know that conduction can take place in solid liquid, and gas. That means, in other words, once you see that maybe if so you go by the states. If it is vacuum, then definitely it won't be by conduction anymore. Okay, then the next part, just to double check. Isaac, do you have the lesson material for today? Have okay, can. Okay, oh yeah, by the way, just to let you all know, my lesson style is that whatever that I write, you are supposed to copy it down too. Okay, so do you all copy all this in? Yeah, so make sure you follow and copy it in. Okay, then next need to know what exactly happens during conduction is where one particle, when it vibrates, it will actually collide with the neighboring particle and pass on the collision. So that's how heat is being transferred. So to be able to better visualize, let me show you this video. I'll just cut short the video like, just to show you the animation. So I'll mute the video. This one, hold on, let me find where's my video. Sorry, give me a while. I'm trying to find my that video. Yeah, over here. Okay, so let's wait for the advertisement to end. I won't be playing the sound, so it's okay that there's no sound coming out. Okay, let's hold on a while. Okay, so things to take note would be, if it is non-metal, what happens is that the heat source would actually cause the particles nearest to the heat source to vibrate. So once they gain heat and vibrate, they will collide with the neighboring particles, transferring them the kinetic energy and thermal energy. Yeah, so then the heat will just get passed down until it reaches the other end. So that's how heat is being conducted in non-metals. If it is metals, there will be additional, the blue color ones. What are the blue color ones called? Correct, it's the free electrons. So besides the Baton relay of atom pass to atom, there's extra small tiny free electron that can, because they are so tiny, they can fly and then reach the other end and then collide with the atom on the other end. So that's how heat is being transferred from one end to the other end very quickly. So that's why metals are better conductors of heat due to the extra free electrons. Okay, so then next would be that so over here is what I've just shown you in the video, where particles will vibrate and then collide and then transferring the thermal energy. So as mentioned just now, that because they have free electrons, that's why they would be able to conduct heat more quickly. So there's actually one common misconception among students that they are unaware of, which is there is this let me show you this another video where they actually show you about a person who actually have a metal block and a wooden block. Then they ask the person to hold and ask them to feel the temperature. Okay, let me find this video of the. Let me see whether can I find it. Or never mind, I think instead of showing the video, I'll just say out verbally. So for example, if right now in the classroom, if I take any existing, maybe one metal and one non-metal. So maybe like I take my water bottle and maybe, okay, I don't really have a metal thing here, but maybe I have an object that is metal. So you know, I'm already in the classroom for so long. So the objects are all at room temperature, right? So be it plastic or be it metal, by right, if I were to scan its temperature, maybe using the infrared thermometer, by right, both are the same temperature. But when you hold a metal versus a plastic, obviously the metal will feel more cooling, right? So do you all know why would a metal feel more cooling, even though both the metal and plastic are at the same temperature? So how would you explain?
Metal conducts heat from your hand to the surrounding.
Close. It will be the metal conduct the heat from the hand to the metal instead more quickly. Yeah, so if they can conduct the heat away from your hand more quickly, that's why your hand will lose heat. That's why your hand will feel cold. Yeah, so take note that sometimes object feels cold is not necessarily because the temperature is lower, but it could be because that they conduct the heat away more quickly. Okay. And then for this topic, you know, right, it's like no calculation, but a lot of sentence writing. Yeah, so for sentence writing wise, how do you answer? So these are the answering techniques. So answering techniques would be like the model answer of like how do you write for explanation answer. So if it's like they ask you explain your answer, you just like copy and paste this in, then you'll be able to score already. Kyra don't have the lesson material, is it? Okay, let me scroll back. I think because you came in late, I showed the lesson material at the start of the lesson. Yep, over here. Can you scan the QR code now? I'm moving on in 3 seconds. So anyone who don't have the lesson material for today, you scan now. Moving on in 3 seconds. 3, 2, 1. Okay, moving on. Okay, so so if they were to ask you maybe like why do we normally when you tap out food is always in like styrofoam box or like plastic containers. If they were to ask you to explain, then you write this because you write that plastic is a poor thermal conductor. It helps to reduce the loss of thermal energy from where to where, something like that. So the blanks over here is for you to fill in the blank according to the question. So maybe if question says styrofoam, then you say that styrofoam have air pocket and you write down air is a poor conductor. So you fill in the blank according to the context of the question. Okay. Yeah, then maybe if they say that why cooking pots and pans are usually made of metals, and then you write down because like metal is a good conductor, they just fill in accordingly then. Okay. But then sometimes they will ask you, right, explain in terms of molecules. So if it's in terms of molecules, then you will need to write this entire paragraph where you need to cover the points that I mentioned just now, where if it's just non-metals, it will be only atoms. But if it's metals, it would be atom plus electron. So where is it? Okay, this one is just wait, let me see. Did they have the electrons? Atoms at the end gain faster. Okay, so depends on whether is it metal or non-metal. If it's metal, you can also include free electrons too. Can we add it in? Since this one is good conductor should have electrons lah. Yeah, so can we add it in? So free electrons and atoms gain thermal energy, then they collide with atoms of the other end. Then transferring the energy to them. Yeah, so let's highlight the key points. Transfer the energy to them. Yeah, then you mentioned about collide also, then vibrate faster, then the whole process repeat itself until you pass down to the other end. Yeah, so these are the keywords. I need to highlight gain energy also. Yeah, so can you follow and highlight all the keywords and help me to amend the answering technique a bit? Thank you. Okay, then moving on. Done, right? Okay, so wait. Before we move on, let's try out a question in the mock exam where you can actually use this answering technique. So it would be question number 5. Yep. So let's take a look at the mock exam question number 5. Yep. So for this question over here, so if you have done it, that's good. If you haven't done it, can you quickly take a look and see what do you think is the answer? So for this question, they say that the diagram shows a boy cooking a sausage on a metal fork, and that he holds the sausage and the fork in a fire, and they're asking you which set of diagram accurately shows. So for this question, the answer would be C. Okay, the answer is C. Why? Because in this case, the heat would always move from the part where the fire is at. So that's why that over here, before heating to after heating. So heat always move from one end to the other end. So since your heat is on the left side of the fork, that's why they will start to vibrate from the left side. So you see left side start to vibrate, then pass down to the middle, then pass down towards the right side. So answer is C. Okay, then moving on, I think, yeah, that's all for now. Okay, let's move back to the notes. Notes would be page 7. Wait. Wait, which page is it? Eh? Hold on, how come mine is different? Yeah, let me go back. Over here. Okay, so then next would be convection. Can you all flip to this page now? So this is page 8. Yeah, page 8, convection. How do you know if convection will occur? So mainly is by, number 1, you go by the states. Yeah, so take note that convection only take place in liquid and gas. So that means once you see that there is solid, you can eliminate it. Yep. As well as for convection to take place, is usually the movement is always hot rise, cold sink. So it's usually kind of like vertical, rise and sink. By the way, can Nikki, can you shift one seat in? You shift further in. Yeah, there's an empty seat, right? Can you shift in? Okay, so for convection, it is the movement of the particles. So need to know how to draw this line. So all these lines are called the convection current. So convection current, it will be like how the substance in the beaker actually moves. So for convection current, you need to know that it's always from the hot part, they rise, cold, they will sink. So usually this is like my favorite question that I always ask my class. Yep, so just to check whether do you all know the answer. So if I have a beaker of water over here, and then I put my Bunsen burner over here, do you all know how to draw the convection current? Yeah, so can you give it a try? Hello, can you follow me and draw it out? You draw a beaker of water, then you have the Bunsen burner at the top here. So how would you draw the convection current? Can you draw it out now? So what's the answer? How to draw? So what's the answer? Alison, maybe you want to do on the table instead so that it's easier to write. You can just shift the chair away. Oh, maybe the pencil case can shift a little bit lah. Just shift a bit, then should have space really. Yeah. Okay, so the answer is, it's a trick question. The answer is no convection current. Why? Because hot always rise, right? If your particle here is so hot already, can it rise further or not? It's already at the surface. It can't rise further, right? That's why you shouldn't be drawing shouldn't be drawing any arrows. So take note, okay, if there were to be such a question, don't leave blank. Because if you leave blank, teacher might think that, is it like you forget to do this question, is it? So you must still do this question. So you should say that, oh, it's no convection current to show that it's attempted, just that you cannot draw any arrows. Okay? Then maybe another one. Okay, let me test you something simpler. The one was a bit complicated. Okay, so what if the Bunsen burner is on the right end? Then how would you draw the convection current? So how to draw the convection current in this case? Can you follow and draw it in? Yeah, draw it inside your notes. Okay, so the correct answer is hot rise, right? That's why you must rise. Then after that, if you cannot turn right, you turn left. Yep, so this would be the convection current. You need to draw it as a continuous line also can, okay? You can draw it as a continuous line. Yeah, so this would be the answer. Yep, so overall, need to know that why is there this movement is because when heated, things will expand, right? And when they expand, particles will rise. So take note that even though we say that there's expansion, take note that it is the spacing between the particles that expand, not the atoms itself. So take note that it's the spacing between the particles that expand. Particle size itself do not expand. Can you follow and copy it down? Yeah, because particles are always microscopic, right? It's like atomic size. So particles cannot become bigger. So it's mainly the spacing between them that increases because they vibrate too much. They keep pushing each other, then push until they become further apart. Yep. Then once the volume increases, then related to density, it will be less dense. Why? Because density, the formula is correct. So how to remember the formula for density, which is mass over volume? You can go by the broken heart shape. Can you see there's a heart shape over here? So the heart shape. Yeah, so for the heart shape, you have a line across it. So it's like, like broken heart shape. Yeah, so you just draw a heart shape. Then after that, you have a line that cuts across. Okay, so it's the broken heart shape. So that's the formula for density. So density is mass over volume. So in this case, if you were to expand, that means your volume increase. If your denominator become bigger, that means your density becomes smaller, right? That's why less dense. And less dense is like lighter. So lighter is like they will float, so they will rise. That's why heated will rise. Then when cold, it will be opposite. It will be denser and it will sink. So all this movement is known as convection current. Okay, so just to check, all of you done copying, right? I shall move on. Okay, so just to share with you some real life examples of convection current would be one of it is is inside the core of the earth. You know that in the core of the earth, there's like magma that's very hot. That's why that sometimes they manage to protrude out to the surface, then it will become like the volcanic eruption instead. Yep, so that's one example of convection. So let me show it to you in this video. Hold on, ah. Yep. So I will mute it so that I can like voice over it. So mainly you need to know that the magma is always hot will rise. Then this is like our ground, our land. So it will cause the land to move. That's why if the two land move and they collide to each other, that results in an earthquake. Yeah, then for the hot magma that touch the land, which is cooler, they will cool down and they will sink. So this can you see the lines over here, like this movement? This movement is called convection current. Okay. So convection current also takes place right now here in the classroom, which is the aircon, where aircon is usually built high up because cold air sinks. Then like, you know, the heat from our body will rise towards the aircon and in turn get cooled down. Yep, so all these are all convection, as mentioned over here. Aircon, hot rise, cold sink. Then for heater, it will be opposite. Aircon, you build it on top. But heater, you build it on the ground because hot always rise. If your heater is on top, then your heat is always on top. Then the people who are like in winter countries, they won't feel the heat because heat always rise. That's why heat need to be below. Then you can experience the heat. Other examples include sea breeze and land breeze. So need to know that for sea breeze, it will take place in the day, while land breeze will happen in the night. Hello, are you writing? So for sea breeze, it would be that the sea blow. That's why B for breeze, B for blow. That means the sea blow the wind. Land breeze means the land blow the wind. So for sea breeze, it would be, how come the sea blow the wind? Is because land, you all know, right, is solid state. Sea water is liquid state. So if you were to talk about conductivity, do you all know which is a better conductor? Is solid or liquid a better conductor? Solid is a better conductor. Why? Okay, let's write this in also. I realize we didn't write it in conduction. Can you flip back to the previous page? Let's write it down that for conduction, need to know the speed. Yep, so from slowest to fastest. Yep, so for slowest, it would be gaseous state. Fastest, it would be solid state. So why is gas the slowest in terms of conduction? Because for gas, the particles are very far, right? So if one particle vibrate, the other particle may not vibrate. So that's why you may not pass on the heat. That's why we would say that you need to be close together. They can do the patent relay faster, right? That's why solid, which is closer, they can pass down the heat more quickly. Okay, then done copying, right? But then if it's convection, take note, it's actually opposite. Okay, so maybe let's add it in. I'm a bit lazy to draw two arrows. So conduction, it will be this way. Convection, it will be reverse. Convection will be this direction. So this is for convection. So for convection, gas would be the fastest instead. Then liquid will be slower. Why? Because for convection, it's about hot rise, cold sink. For gas very easy to float, right? But liquid isn't it very hard to float upwards? Because liquid is denser. Gas, you all learned before, right? Like particulate nature of matter, you all learned that gas, the particles are far apart. So very low density. So low density, they will float up. So that's why gas, they will move faster. Liquid, it will be slower. So take note, okay, it's directly opposite. Gas can be fastest or slowest, depending on is it conduction or convection. Okay, so then now, if I come back to over here, based on this information over here, okay, let me shift this, what's blocking my screen? Okay, so in this case, since we mentioned that the land is solid, that's why solid would be better conductor. So if solid is a better conductor of thermal energy, that means solid, it would be warmer during the day, right? As compared to liquid. Because liquid is poorer conductor. Can you follow and copy it down? Are you copying? Yeah, write it down. So poorer conductor, usually it would be cooler. No space. Hold on. Okay, so then in this case, since the land is warmer, that's why the air above the land will be heated lor. That's why hot, rise. Then liquid, since it's cooler, cold, sink. But then if it sink, it need to move somewhere, right? It cannot sink endlessly, right? So since it cannot turn right, because you see, if you try to turn right, the right side also got particles sinking. That's why the only way is you can only turn left. Yeah, so that's why in the end you turn left and it becomes the sea blow the wind. That's why it becomes sea breeze. Okay, then for land breeze over here, land breeze, it would be at night. So at night, it is cooling, right? And since solid is a better conductor, that means at night, solid will become colder, right? Because like for metals which are better conductors, metals will also be cooler when it's cold, right? Yeah, so that's why generally is that better conductors will be either hotter faster or cooler faster. So in this case, at night, it will be cooler more quickly as compared to the land, which is liquid, which is poor conductor. Yeah, then again, same thing, hot rise, cold sink. So for the liquid side, which is warmer, heated up, then it will rise. Then the cooler side, it will sink. Then just complete the arrow lah. Just finish up the arrow, then done. That will be the convection current. That's all. So done copying, right? Okay, then next, let's move on to the answering techniques. So if it's like open-ended question, then how would you answer? So depend on the situation. Are you heating things up? Like maybe is it like heater or maybe like like then like the sea breeze like in the day. Yeah, so if it's being heated up, this would be the way you write. If it's being cooled down, like maybe you put a fruit inside the fridge, for example. So things that is cooling down, or maybe this classroom got aircon to cool it down, cool down, then this would be the answering technique. Yep, so key points you need to have would be number one, you should always tell me about the temperature. So you see, like gain heat or cooler. Then the second point would be expand. But take note, the second sentence, don't write contract. Why? The reason is because when a substance is being heated, you can't possibly contract it, right? When you heat things up, they can't possibly contract. So that's why second sentence, don't write contract. Then the third point you write is about the density. Yep, so you write about less dense or more dense. Then the fourth point would be how they move. So rise or sink. Then, of course, this is the topic on convection. Obviously, you need to have the keyword convection current, right? That's why I need to have this part, convection current. Done. So this would be how you write it. For heating maybe a place or substance up. But if it's being cooled, the key points are similar again. So the first point you write is always on the temperature, like you see loose heat or warmer. Then second point, you always write about the expansion, contraction. So same thing, you write contract, don't write expand. Why? The reason is because you are cooling things down. If you are cooling things down, like a fridge cannot expand substances. Only when heated, then can expand. So that's why you see, only write contract, don't write expand. Then next would be the density. Contract would be denser, while expand would be, warmer would be less dense. Then lastly, it would be movement like rise or sink. Then of course, this is a convection question. Must have the keyword convection current. Done. So these are the key points. Highlighted. Yeah, so follow and highlight it. Okay, so let's now take a look at question 22B of the mock exam paper. Question 22B. Okay, so let's take a look at question 22B over here. Okay, actually A you can do. Okay, so yep, so there's this part of question. Okay, so far based on what I've taught, you will be able to do A and B part 1 and B part 2. Okay, so let's do it together. So for part A, they're asking you to based on what you see over here, name the process that the heat is being transferred through the base of the metal pan. So class, what do you write as the answer? So far I only teach conduction or convection, right? So which one do you think is the answer? Heat transfer through the base of the metal pan. So first, let's identify what state is the base of the metal pan. Solid, right? So between conduction and convection, which one do you think is it? Conduction, because convection cannot take place for solid, right? Convection is only for liquid or gas. So that's why the answer is conduction. Moving on to B part 1. You're supposed to draw the movement of the water when it is heated. So do you all know how to draw the convection current? So if you haven't seen, really draw it in. So take note, it's the movement of the water. So in this case, you're drawing for air, so it's not correct. So it's the movement of the water inside. So the water inside, how do you draw the convection current? So remember, I told you hot always rise, right? So how do you draw? From here, it will rise, correct. Then go to the top. Can go up further? Cannot, right? Then what do? You will have to turn left or right, right? So maybe you can turn left and turn right. Yep, so done. This would be the answer. Yes. Not correct because the heat is in the center. So the center part must all rise. That's why the extreme top left, right? Can you see that this region over here is the coldest because it's the furthest from the heat source. That's why these two ends must sink. That's why it shouldn't be in a circle because these two ends must sink. So can you see these two ends is sinking down. Then this end also sinking down. Okay, the two extreme ends here must be sinking downwards. That's why this would be the answer. Okay, so moving on to the next part. It would be part 2. You're supposed to explain the movement of the water in B part 1. So whenever it's explained, can you all lower your volume, please? Thank you. So as mentioned just now, whenever there's the word explain, think of using the answering technique. So actually this topic, you can score in exam 1. Because I already give you all the nice model answer already. You just need to use the model answer, you write it in will do. So in this case, which answering technique should we be using? Which answering technique should we be using? The conduction one or the convection one? Convection. So let's now refer back to the convection page. So for convection, there is 2 of them, right? Which one should we choose? Which one should we choose? Top one or bottom one? Top one, right? Because you got Bunsen burner, right? And then do you copy this whole paragraph in? Yeah, so when you were doing the mock exam paper, if you refer to the notes, you copy everything in, then full marks video done. So that means the answer for B part 1, I'm not going to flash the answer, I will just show it to you over here. So for B part 2, the answer would be be specific. Don't say water. If you say water, water is everywhere. Which water are you talking about? It's the water at the bottom versus the water at the top. Done. So this will be the answer. That's all. Okay. So this is the answer for B part 2. Okay, so if you need time to do correction, how about this? You write down the page number will do. Yeah, so for B part 2, you just write down that refer to notes page 8. Okay, you just copy the whole paragraph in lah. Will do. Done. Okay, so I shall move on. Okay, so moving on to the next part over here on radiation. How do you tell, like for so many methods for conduction, convection, radiation, how do you tell that it's radiation? Mainly is, again, same thing, you can go by the states. Yeah, so radiation is the only one that can occur through vacuum. As well as radiation is usually at a distance away. You know, like for conduction, just now I was saying, right? Conduction must touch, like for example, if this is a metal rod and I want to use my body heat to heat up the metal rod, I must touch, correct? So conduction happens when you touch the object. The heat must touch the object. As compared to radiation, it should be at the distance. That's how the heat from the sun reach us. That's why you see sun is not touching us, but we actually gain the heat. So Skyline is asking, at which date does radiation occurs? You deleted it, okay, cannot see anymore. Okay, so then next would be that for radiation, also need to know that it's very, very fast. Yeah, because radiation actually happen at the speed of light. So that means if question were to ask you, what's the main method of heat transfer? The answer would be radiation, because conduction, convection very slow. Conduction is like, the Baton relay, one particle vibrate, collide. So conduction is very slow. Convection also takes time, because when you on the aircon, it takes time for the whole room to cool down, because the particles must like rise and sink. So all this movement takes time. But radiation is at the speed of light. It's like immediately. That's why radiation is the fastest. So if there were to be 3 processes happening and they ask for main, you choose radiation. Of course, radiation would be the fastest. As well as for radiation, it would be in all directions. Because if you compare it with convection, convection is only rise or sink, right? You realize it's only rise or sink. But for radiation, it would be actually in all directions. Yeah, can be like diagonal, forward, left, right, up, down. Yep, so that's how you can tell that it's radiation. Okay, then next would be need to know how to decide is it good or poor. So for conduction and convection, we decide based on the state, correct? Is it like solid, liquid, or gas? But for radiation, how do we decide? It will be based on these 4 factors. Okay, so for the first one is on colors. So you need to know that generally is that if they are good in radiator, that means they are also good absorber and emitter. Something like, if it's a good conductor, they will gain heat fast and lose heat fast, right? Correct? It's a two-way thing. So that's why you absorb and emit should be the same speed. So if it's poor radiator, it should be a poor absorber and poor emitter. Okay, so let me now go through with you each of the factor one by one. We start off with the colors first. So first is okay, maybe now maybe we talk about a place that is hot. So maybe maybe at the beach. Okay, so I draw some coconut tree. Okay, so then now if I'm at the beach, then now it's like, I find that like, beach usually not much shelter, then it's very hot, right? So now my question is, if I'm at the beach, okay, maybe I'm the very conservative kind. Maybe I'm not the kind that like, I will like wear bikini kind or like topless kind. Yeah, so maybe like I'm still very shy, okay, I still wear t-shirt. Okay, so in this case, if you're still wearing a shirt, right? What color shirt do you usually see people wearing at the beach? Do you see them wearing dark color or do you see people wearing bright color at the beach? And they usually wear bright colors, right? Why? It's not just because beach theme must be bright. It's not because only like that. The reason is because it's linked to science also. It's to keep them cooling. Why? Okay, so let's take a look. So you know that how does heat flow? Heat always move from what temperature to what temperature? How does heat flow? Heat always move from high to low temperature, right? So now you take a look. When you're at the beach, how would the heat flow? You realize at the beach you will sweat, right? Why? Because you gain heat. Because the surrounding is hotter than your body. So if you keep on gain heat, we would say that now you are absorber of heat. Do you agree? Absorber. Can you follow me and draw in this cartoon? Can you find some space to draw it in? Hello, you're supposed to follow and copy it down, please. Yep, so draw in the cartoon. Yep, so at the beach, by right, you will be constantly absorbing the heat. That's why you will perspire at the beach. So now, if you're at the beach, in order to not sweat that much, because you sweat too much, very uncomfortable, right? So to reduce my sweating, best is my shirt. Should it be a good absorber or poor absorber? Poor, right? Because you don't want to sweat so much. That's why poor absorber, you see? Poor absorber, isn't it bright color? That is why people at the beach, they wear bright color. So I'm going to write it down over here. So usually people wear bright color clothes. The reason is because you want the shirt to be a poor absorber so that you can stay cool. Okay, then now, okay, maybe I don't talk about hot place. Now I change to a cold place. So maybe like now at OVERMUGGED, maybe I on aircon. Then for example, if my aircon like I blast until like 16 degrees Celsius and like like very, very, very cold, like freezing. Yeah, so if it's freezing, then maybe I a bit lazy to bring jacket. Then if I know that the place is very cold, but I lazy to bring jacket, so let's decide what color clothes we should wear so that without a jacket, I can still stay warm. So if it's at a very, very cold place, what color clothes do you think you should wear to stay warm?
Black.
Black? Okay, so let's go through. So this time round, I haven't reviewed the answer. Is it correct or wrong? So is it black? Okay, so first, heat. How does heat flow? As what you mentioned, right? Heat always move from what temperature to what temperature? Heat always move from high to low temperature, right? So now let's compare. The aircon, I say I on like 16 degree, right? So if the aircon is 16 degrees Celsius versus my body, what's our body temperature? Around 36 degrees Celsius. So how does heat flow? Flow out or flow in? Heat will flow out, right? So if heat flow out, that means the shirt is actually an emitter of radiation. Do you agree? because you lose heat. So then in this case, since it's emitter of heat, then now I say that I don't want to shiver, right? Because it might be too cold. So in this case, what you should do is the clothes, should it be good emitter or poor emitter to stay warm? It should be poor emitter, right? Because you don't want to keep emitting the heat, I will shiver and feel very cold. Yeah, so that's why in this case, you want it to be poor emitter. And let's check. Poor emitter, it is bright color. So that's why actually the clothes you should wear is not black. You should be wearing bright color. Okay, I'll write it down. So that means, in other words, whenever you see clothes that is black in color, it's just to act cool only. It doesn't have any benefit. You see, cold or hot place, you should wear bright color, right? So black color is just to act cool only. It doesn't help you in staying cool or staying warm. Okay? So clothes you wear bright color. But of course, you do see that there are things that are designed in black color, right? Like for example, cooking pots and pans. You know that cooking pots and pans, the wok, the wok that the chef use, they are all black in color. So why are those in black in color? Got reason also. So let's draw it out also. So if you draw a cooking wok, right? Then here got fire. Okay, so this is like a wok. In case you don't understand what am I drawing, I'm trying to draw a wok. Or maybe cooking pot or cooking pan. Yeah, usually pots, pans, they tend to be in black color. Okay, so I'm draw the handle over here. Okay, so why is cooking pot and pan, how come they are black in color? The reason is because you are cooking the food, right? That means, do you realize the surface over here need to gain heat? To gain heat, that means the surface here need to be an absorber, right? And to cook the food, usually we want to cook the food faster, ma. Because if you cook the food so slow, then it will take very long, correct? And then later what's the customer later angry, right? How you think it take so long to serve the food? Yeah, so that's why in this case, we would want it to be a better or poorer absorber. Which one is it? Is it better or poorer for wok? Better, because you want to cook fast. That's why it should be a better absorber. Then you see, better absorber, isn't it dark color? That is why the pan and wok, they are usually black in color. The reason is so that to be better absorber. Okay, so done for the colors. Okay, so that means only clothes wise, black is useless lah. But black still is useful in other aspects. Like you see, like the cooking pots and pans, we can still have it in black color. Okay, so then moving on to the next part, it would be the surface, dull versus shiny. The most common example for surface, it would be aluminium foil, right? Because aluminium foil, one side is dull, one side is shiny. So if you do not know that aluminium foil got two sides, tonight you go home and ask your parents to show you aluminium foil. There will be two sides. Okay? So for aluminium foil, one side is dull, one side is shiny. So then now let's decide. Do you all know which is the side that you are supposed to wrap the food in? So that means, like example, I got the food over here, right? Should I be using the shiny side to wrap the food? Or should I be using the dull side to wrap the food? So which is the surface that touch the food? Is it shiny? Okay, come. Then some say dull. Okay, come. Let's figure it out together, okay? So now let's draw it out again. Let's doodle a lot. Yeah, today doodling a lot of cartoons. Okay, so this is my food. Then now let me wrap with aluminium foil. Okay, wait. I think I draw the aluminium foil first, easier. Okay, so I draw the aluminium foil. Can you follow me and draw in the aluminium foil now? Okay, then inside I put the food. Hello, draw in, draw in. Are you copying? Can you follow and copy down? Okay, so over here I have the food with the aluminium foil. Okay, so I label this aluminium foil. Okay, so now you all are saying like different answer, right? Some say shiny inside, some say dull inside. Okay, so what's the answer? Okay, so first, aluminium. Usually we use it to cook food, right? Correct. So it can be like maybe barbecue, got fire, or maybe it can be like for oven. Oven you bake things, also got heat from surrounding, right? So overall, we know that for the external layer, there is actually a gain in heat, correct? Yeah, so this surface, since they are supposed to gain heat, that means, do you want them to gain heat faster or do you want them to gain heat slower? You want them to gain heat faster, right? Because you want to cook the food fast. Yeah, so that's why over here it should be better absorber. Yeah, so are you copying? Yeah, make sure you copy down. Then next is since it's a better absorber, then in this case, if you refer to this row over here, better absorber, should it be dull or shiny? So how? It should be down, right? Cause better. So that's why the outer surface is down. That's why just now I was asking you all, right, which side should touch the inside? It should be the opposite of down, which is shiny. So it's the shiny side that touch the inside. Yeah, so let's write it down. Why is it shiny on the inside? Because you need to first, number one, the heat from the food. You don't want it to escape, right? You want the heat to get trapped inside. So since you want the heat to get trapped inside, best is it's shiny, because you know, right, shiny can reflect. Yeah, so that's why in this case, you shiny to reflect the heat back in. So let's write it down. Shiny is so that you can reflect the heat, as well as if in terms of absorber or emitter. Do you realize this is like, you don't want the heat to escape from the food. If you don't want the heat to escape from the food, isn't it means that best it should be escape? Escape, should I use the word absorber or emitter? If I don't want the heat to escape, you see over here, I don't want the heat to escape. Escape, I should use the word emitter. And should it be poor or good emitter? Good emitter, then it wouldn't heat keep escaping. No, right? It should be poor emitter, so that the heat emit out slowly, so that my heat can get trapped inside and continue to cook the food. Okay, so that's why the side should be shiny, so that it's poor emitter. Then you don't keep losing heat. Then you can trap the heat to continue cook the food. Yep, so that is why always shiny inside, dull outside. But then the thing is that, you know, sometimes like if you are going for like maybe barbecue, like maybe family event, like I don't think you have time to think of what did Miss say at Overmark about like which side shiny, which side down, which side touch the food. I don't think you have time to go and recall all the physics concept, right? So a quick way to figure it out is you base on this. You know, food need to be clean, right? Because if food is dirty, we eat, then stomach pain, right? Correct? So that's why in order for food to be clean, you base on shiny and dull. Which one give a cleaner vibe? The shiny or the dull side? The shiny give a cleaner vibe, right? And that's why the cleaner side should touch the food. Oh. That's why you see, as shown over here also, it matches, which is shiny should actually be on the inside. Okay? Yep, so that's why shiny inside, dull outside. Okay, then moving on to the third point, which is temperature. So temperature, I think quite common sense, right? Because like if it is like hotter, obviously what it can like emit a lot of heat, right? Then if it's like lower temperature, then it can only emit out a little bit of heat. Same for surface area also. If the surface is very big, then you got a lot of area to emit and absorb, right? But if your surface area so tiny like that, then you can only have a little bit of heat absorb and emit. Done. So how is it better? Clearer? Okay, so now that you all are clearer, okay, then let's see how to answer open-ended question using the answering technique over here. So take note, okay, that for radiation, don't use the word conduct anymore, because conduct is for conduction. This is radiation. Radiation, you use the word emitter and absorber instead. Yep. Then this is the answering technique. So depending on the heat flow, so how do you know when to use the word absorber and when to use the word emitter? Remember just now, we base on how does heat flow. Heat always move from high to low temperature. So to decide, right, the word to choose, it would be based on heat travel. So that means, do you choose absorber or do you choose emitter? You see how the heat flow. If the heat move from high to low, like out of my body, that's emit. If the heat is moving into my body, like high temperature outside to low temperature of my body, that would be absorber. Okay, so always find out where is the higher temperature, where's the lower temperature. That's how you decide absorber or emitter. Yep. Okay, then next is whenever it's absorber or emitter, can you use the correct word? It's absorber and emitter of radiation. Because you need to know that this word absorber and emitter, you only see in the radiation chapter. You don't see in convection, you don't see in conduction, right? For the word absorber and emitter. So since this word is uniquely for radiation, must use the word absorber or emitter of radiation. The word infrared, I leave it to your school teacher. If your school teacher say must have the word infrared, you put it in. If your teacher say, oh, don't need infrared, then you just say emitters of radiation will do. Okay, then next would be that you need to know that if it is better, like example, a better student, of course will have more marks, right, for the exam, also greater lah, okay? Then if it's a poorer student or maybe a poorer person, like the person no money, so poorer, obviously they will have lower amount in their savings account, something like that. Yeah, so lower it will be poorer. Then next is for absorber and emitter, depends. If it is an absorber, then obviously you choose the word gain. If it is an emitter, then obviously you choose the word loss lah. Okay? Because absorb means gain, emit means loss. Then of course need to write down the direction of heat flow is like from where to where. Yep, so this is how you use it. So whenever it's explained, remember to use this template, okay? So let's now take a look at question 22C of the mock exam paper. Question 22C. Okay, so for question 22C, over here, they say that the pen had a polished and silvery metallic surface. Explain how this feature minimizes heat loss from the metal pen. Okay, so whenever they say polish, which word? So what exactly is polish? Which word can you link it to? Shiny, very good. Then silver, it would be linked to the color, right? Because remember, if you were to refer back to the table, let me show it to you. Now over here, can you see the word silver? So take note, okay, white is actually the middle color. So that means the two extreme end is black and silver. So that's why when you see the word silver, when you see the word polish or shiny, it's a hint to you. This is a radiation question. Yep, so in this case, so right now, you know that this is a radiation question. And whenever they have the word explain, you need to remember to use the answering technique. Yep, so just copy and paste the entire answering technique in. So how do we answer for this question? Okay, I'm going to use the answering technique. Can you write down the word AT like answering technique? Or you spell out in full also can. So AT means answering technique. Can you write it down at the side of part C? Hello, have you written this word AT or answering technique beside part C? Write it in. Okay, come, let's use the answering technique. So over here, so we just fill in the blank accordingly then. Okay, so for the first blank, what should we be writing? What should you write for the first blank? What did the question say? So they use polish, right? Polish is like silver, correct? So one is silvery and polish is shiny, right? So polish, sorry, so that means you write silvery and shiny surfaces or surface is, then this time around you check the table above. So based on the table above, silver, is it better or poorer? Poorer, because based on the table on top is poorer, right? Then this time around, you need to decide, is it absorber or emitter? So you read the question. What did they say? Is to minimize heat. Read the question. Heat loss. So which word should we use? Heat loss. Heat loss, which word should we use? Hello. Heat loss, which word should we use? Emitter, correct. Yep, so it will be poorer emitter of infrared radiation. Okay, this time around we are not comparing anything, so there is no need the then part lah. Just until here, to stop. Then continue. If it's poorer, which word should we choose? Is it greater or lower? Correct. It should be lower. Then just copy until here. Emitter. Emitter, is it gain or lost? Lost, correct. Because emit means you lose it. Yeah, so lost by radiation from where to where? So in this case, you read the question. It's lost from the what is inside the pen. About what is inside the metal pen. So we always go from the starting. Correct. Thank you. And yeah, water to the surrounding. Yeah, so try not to write pen because pen is like in between. Because it's water, then pen, then surrounding ma. Yeah, so you don't do the in between. You always start from the first and end with the last. So that's why if it's got water, pen, surrounding, you write water to surrounding. Or you write all three, you get water to pen to surrounding also can. Yeah, then done already. Also, this would be the answer for part C. Okay? Yeah, so make use of the answering techniques. So answering technique is there to help you see score full marks for your open-ended answer. So this one is just, you just have to play your part in studying. You just study hard. You just use the answering technique, then you can score. Of course, if you don't want to memorize, can lah, but you just need to make sure that all the keywords are present. So it's not a hard rule, yeah, but I will strongly recommend that you study. Done. Okay, so let's continue on. So next would be question number 7 of the MCQ. Let's take a look at question number 7. Over here. So for this question, they said that the diagram shows 4 similar cans Each can contains the same volume of water initially and at 80 degrees Celsius. And after 5 minutes, they ask you which can is the coolest water. So first thing again, you need to decide, is it absorber or emitter? So in this case, what do you all think? Is it an absorber or emitter? Emitter, correct? Because your water is so hot. So that's why the can would be an emitter. Write it down. Then now, can you refer back to the table in the notes? Yeah, so you refer back to notes page 9. Then you choose. Yeah, refer to notes page 9 and choose. So what's your answer? Answer is A. Can? Yeah, because both dull and black, they are both better. Yeah, so both of them are better emitter. Yep, so that's why you choose dull and black. Okay, just refer to the column for the better one. Done. Okay, so yeah, let's move on to the next part of the notes. I was here. Haven't finished yet. Come, let's continue on the next part over here. Application question. Okay, so need to know that. Can I have silence, please? Ready? Okay, so for application question, yep, so over here they're asking you to state the feature and the method of thermal energy transfer that's involved and explain your answer. Okay, so first, there is vacuum, as you can see. So what's the purpose of vacuum? Vacuum would actually reduce thermal energy by conduction and convection. Actually, not even reduce. It can actually totally prevent. Yeah, because conduction and convection totally cannot happen in the vacuum. Yep, so it can even go up to prevent. Yep, so the explanation is because conduction, convection need a medium temperature. Next, for this case over here, it is silver glass wall. How does it help to maintain the temperature? So take note that for this kind of vacuum flask, the temperature always maintain the same. So that means cold drink will remain cold, and then for hot drink, it will remain hot. That's the ability of thermal flask. Can you all follow and write it down? Hello, are you copying? Cold drink will remain cold. Hot drink will remain hot. How? Because there's also this silver glass walls. So you see, if your drink is cold, heat cannot enter. Or if your drink is hot, heat cannot exit because of the vacuum. Right? Because vacuum don't allow conduction and convection. Okay, then next is there also additional, when you look inside a thermal flask, it's usually silver in color on the inside. Why? Because for the silver glass wall, silver is, you can see in radiation, correct? Yeah, silver, if you look at the top of your notes, the same page, is poor radiator. So poor radiator, that means you reduce thermal energy by radiation. So that means heat doesn't travel in easily or heat doesn't travel out easily. So they will maintain that same temperature. Done. Okay, so before I move on, let me test you all a little bit to see whether you understand what I've been teaching so far. So if I were to ask you, what is the main processes of thermal energy loss in styrofoam, then what do you all think is the answer? Okay, I repeat my question, I put here. If there is a worksheet question asking you, what is the main process of thermal energy loss in styrofoam? Do you all know what's the answer? Do you know what's the answer? Okay, so maybe we go by voting, okay? So who feels that there is conduction? You raise your hand. Who feels that conduction is one of the answer? Can you raise your hand? So the rest of you all disagree that conduction is the answer. Is it? Okay, I see more hands raising up. And those online also raising hand. Okay, good. Yep. Actually, the answer is you should raise your hand. If you didn't raise your hand, then oh no, you're wrong. So yep, one of the answer is conduction. Okay, then this time round they only asking what. If they continue ask you, explain your answer, then how are you going to explain your answer? Why do we choose conduction? So why do we choose conduction? Why do you choose conduction? For those of you who raise hand. So maybe another part. Yes, correct, very good. So take note, okay, cannot just directly say that styrofoam is poor conductor. Cannot. You must tell me that styrofoam has air spaces, air pockets. That's why it is a poor conductor. Okay, so it's the air that is poor conductor. It's not the styrofoam that is the poor conductor. Good, come, let's write it down. So the answer would be, can you find somewhere to copy down? It's because styrofoam has air pockets and it is air that is a poor conductor. So take note that do not use the word insulator. Okay, so this topic just use good or poor conductor. Don't use the word insulator. Also, don't say that styrofoam is poor conductor. Yeah, styrofoam is poor conductor, not accepted. You must talk about the air pockets. Same for animal fur also. You know, animal fur, you cannot say fur is a poor conductor. You must say that there is air pockets trapped in the fur of the animal or the feather of the birds that keeps them warm. Yeah, so must talk about the air pockets. Okay, so done for conduction. Yeah, so that's why I want to ask you also. So after conduction, will convection and radiation happen? Okay, so come back to this question. We haven't finished yet. So just now I only asked you for conduction, right? How about convection? Do you think is it the main processes of thermal energy loss in styrofoam? For convection. Is it convection? So if you think it's convection, to include convection as the answer, you raise your hand. Okay, very good. You never raise hand. That's good. Should not include convection. Yeah, because mainly styrofoam is the air pocket. So air pocket is the poor conductor. That's why in other words, also should not include radiation. So that means, okay, how to say like actually all three processes are happening. Because you see, if styrofoam box you cover means the hot air from the food cannot rise, right? So yeah, there is also convection that is being reduced. There's also so there's convection and radiation all being reduced. But the thing is that if they ask for main, you choose the main one. So this time around, because it's air pocket, so the main one is conduction. So you choose conduction, even though all three happens. So the keyword is because of the word main. Can you underline the word main? Hello, can you underline the word main process? Main. Underline the word main. Underline. Okay, then now let me address Skyly's question. So you're asking at which state does radiation occur the fastest? It would be vacuum because vacuum no particles blocking. Okay, so done for this part here. Okay, so give me a while. Okay, let me see. Is there any more questions? I think mainly that's about it. Okay, let's continue on with the next page. This chapter not done yet. Okay, so moving on to the next page over here. So for thermal energy topic also, they cover on points about the expansion and contraction, right? Okay, so we need to know the different scenarios. So first, it would be that you need to know there's this thing called bimetallic strip. What is bimetallic strip? Bimetallic strip refers to, okay, by example, yes. So if I say, for example, like maybe someone or maybe me, if I say I'm bisexual, what does it mean by I'm bisexual? What does it mean by bisexual if I say I'm bisexual? I like both gender, right? I like guys, I also like girls. Yeah, so that's bi. Okay, so usually when we say the word bi, okay, but I'm not like, okay, I'm normal. Okay, so for bi, you clarify. You have the wrong impression. Someone today first time seeing me. Okay, so for bi, it just means two lah. Okay, that means like bisexual means you like two genders lor. So bimetallic strip means is two metal strip. Yep. So then in this case, it would be two metal strips stuck together. So they would be actually glued together. So in this case, it would be that for the two metals together, you need to know that the most common one that is being asked, it would be actually brass. So brass is always the one that expand and contract the most. That means in other words, brass is like the best conductor of heat, something like that. The rest don't need to know, just only need to know brass good enough. Yeah. Okay, so then for brass, right, is that because for brass, it is able to expand and contract the most. That's why you see, once it is heated, okay, so this is a case where it's being heated. This is the case where it's being cooled. Yeah, so when it's being heated, it would be able to expand more. So you just imagine, if both metals originally same length. So if both of them originally same length, if the top is brass, and we said that brass expand the most, that means brass, it will become like longer. Lor. Yep, so can you follow me and draw it out? So if brass expand more means brass will be longer as compared to the below. So the below will expand lesser. Lah. Okay, so the focus is just brass. Okay, so if the focus is brass, then this time around, if it expand the most, that's why can you see that is longer. But then I said that the two metals are stuck together. So that means you cannot like separate them. Yeah, so that's why the two ends must be stuck together. So if the two ends are stuck together, can you tell that the top metal is actually bending downwards? That's why you see the whole strip will actually bend downwards. Lor. You also need to know how to how it moves. Okay, then moving on to the next part here for cooling. So let's draw it likewise again. So I'll draw two metal strips of the same length. Then the brass is on top. So now if it's cooled, that means it will become shorter. So that means brass will become much shorter than the other metal. So can you see my brass, I contract more than the below metal? Hello, are you copying? Can you follow and copy it down? So if brass is contract more, the same thing. The two ends must be aligned. That means this end and this end must be aligned. Can you see that if the below is longer, it will push it up, correct? So that's why in this case, we would say that the below will push up. So can you see? It got pushed upwards. Yeah, like that long. So that's why in conclusion, it would be that the brass will get pushed upwards. Can also need to know. So actually, why do you need to learn this bimetallic strip? It's because bimetallic strip is the one that can is the one that controls temperature. For example, like things that you need to maintain same temperature, like aircon. Aircon we need to maintain based on what my remote control show, right? Or maybe if it's like the let me see, maybe oven or iron. Because oven and iron, all these must maintain at the same temperature, right? Maybe I bake at 200 degrees Celsius, and then it must maintain at 200 degrees Celsius. Yep, so that's why for such bimetallic strip, because of its bending, you will be able to open and close the electrical circuit. So for example, like maybe this strip over here, I connect to a wire. So can you see, maybe if here is the wire, if it's too cold, and then it will open up. So maybe like the aircon room, if you keep blowing out the cold air, then if it's too cold, it will bend up. Then you see open circuit. So that means it stopped blowing cold air because the room may be too cold. Then once the room get warmer and warmer, then it will bend down, bend down, bend down. You touch, and then once it bend down and touch, and then close again, then my aircon start to blow cold air again. That's why I don't know whether you all remember like certain aircon. I don't know whether at home you all do notice or not. Sometimes the aircon will blow, 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 then silence. Then blow, 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 then silence. You all experience such aircon before? It's because of the bimetallic strip keep moving. When too cold, they will move up. That's why open circuit, silence, cause no electricity flowing. Then once the room start to get warmer and warmer, then it gets warmer, right? Warmer will bend down and touch. Touch, then you start to hear the aircon blowing again. Yeah, so that's the effect of the aircon, how it regulates the temperature. You can go inside, there's another teacher. Yeah. Okay, so then another one, it would be like maybe oven, like oven, you want to like keep it at maybe 200 degrees Celsius, the same temperature. So then same thing, if the whole oven, you keep on heat until too hot, then it will like bend down. Then maybe if I have a wire here, it bend down, not touching, open circuit. Then once the oven cool down, and then it will bend back up, then in the end you can like, have current flowing again. Yep, so that is how bimetallic strip works to control the temperature. Okay, then another application you need to know, it would be on the bends in the pipe. So for bends in the pipe, it would be to allow you to transport hot and cold water without cracking. Yep, so in this case, it would be like, if it's like hot, then when they expand, you see you can bend inwards. Here also, you can like bend outwards. So you got room for expansion as compared to a straight pipe. If the pipe is straight, and then you expand wiper, they will bulge outward, then it might crack, right? Yeah, then the water might leak. So that's why usually they put it in bends so that you got room for expansion and contraction. So if contract, just move down, then this one just shrink to the left and right. Yeah. Okay, then next would be electrical cables. Take note, this one is not for expansion, okay? So maybe let's write it clearly. So for the first one, bimetallic strip is to account for both expansion and contraction. Then for the bends in pipe, it will be also for both expansion and contraction. Hello, can you write it down? Because sometimes they will ask you like, which of the application is for expansion only. And then these two cannot, because these two is expansion and contraction. Done copying? Then for cables, it will be only contraction only. Because for cables, is why did they hang it so loosely? I think you might have seen it before when you go to other countries, right? Like this kind of cables, I think I saw it a lot in Japan, in Malaysia. Yeah, so all these wires, why are they hang loosely? Is because in case of cold weather, they will contract. And then when they contract, it will become like straighter and straighter and straighter. So then when it's straightened, then at least it still won't break. Yeah, so for cables, it would be for contraction only. Everyone done copying, right? Okay, so moving on to the next part. Here it would be the gaps between the tiles. So need to know that for gaps between the tiles, it would be for expansion. Yeah, because so that the tiles would not bulge upwards. Yeah, so got the gaps so that they won't bulge upwards. They got a gap to expand into the gap. And then on the rollers over here, it would be for expansion and contraction. Hello, are you copying? Write it down. Hello, everyone. Write it down, please. Okay, so in this case, for the expansion and contraction, why? Because they purposely have a gap with wheels. So that means you can actually like move in and move out. Yeah, so when it's hot day, when expand, it will move in and close the gap. Then when it's a hot day, it will just like contract, but the gap still won't be that big. Yeah, it is still of a size that is still like smaller than the wheel of the car lah. Yeah, so that's why the car won't like get stuck inside the gap lah. Yeah, so it's still quite small, so it's still okay. So that the bridge it won't like expand and then like bulge outward. If not later the bridge surface become uneven. Yeah, like that. Okay, then I think I'm done already for the topic of thermal energy. Yay. Okay, so for Shana, the lesson material I showed you at the start, but I think because you were late for class, can you quickly scan it now? I'll move on in 3 seconds for Shana. 3, 2, 1. Okay, moving on. Okay, so now let me see. Is there any more question on thermal energy? Yes, let's take a look at question number 6 of the mock exam paper. Yep, let's take a look at this question. So it's on the bimetallic strip. Are you at question number 6 now? Hello, I'm at question number 6. Okay, so for question number 6 over here, they say that a bimetallic strip is made with two materials, X and Y. A change in temperature causes the strip to bend. So this time round, let's take a look. They are asking you which of the following statement is true. So they said that X contract less than Y. Let's check. Is X shorter? So you see X is until here. Y is until here. Can you see that X is shorter, Y is longer? So if X contract, it should contract more, right? Can you see that because X is shorter? And wait. Anyways, when you are heating shouldn't be a contraction, right? So that's why this one in the first place is wrong, because when you heat things, it should expand, not contract. It is correct. Contract is cold, expand is cool. This is also incorrect. Because cool down, it should be contract, not expand. Then the last part here, expand is heated. Yep, this is correct. Okay, so now let's confirm which one more, which one less. Okay, so let's take a look. They say that X contract more. X contract more seems correct because X is shorter, right? Yeah, so that's why X contract more. So yeah, this is correct. So that's why B is the correct answer. For D, they say they expand more when heated. Is X longer? No one. X is shorter. So it should expand less because X is shorter than Y. So if X is shorter, means it expand less. And so the correct answer is B. Yep, done. That's all for this topic. Okay, so yep, so done for this chapter. Let's now move on to the next topic. Yep, so let's move on to the next chapter, which is chemical changes. Over here. Can you all flip to your notes, page 11? Yeah, page 11 of the notes. Shana, can you download from the OVERMUGGED website? I don't want to keep on break the flow of the lesson. Download from OVERMUGGED website. Okay, so for chemical changes, need to know this topic. There are two categories. There is physical change and chemical change. Yeah, so for physical versus chemical change, need to know physical change mainly is the change in physical state. Come, let's write it down. Hello. Physical change refers to the change in physical state. As compared to chemical change, refers to chemical reactions. Okay, so for the change in physical state, it will be like, like boiling, freezing, melting, condensation kind. Yep, so that's why in this case, it would be no new substance form, because when you freeze water or you boil water, it is still water, right? There is no change in states. Okay, then the properties will still be the same because it is still water, correct? As well as it would be reversible, because if you were to freeze water, you can melt water. So for Lucas, if you're asking tearing paper, there's no chemical reaction involved, right? So then that would be a physical change in size. So physical change not only include change in state, it can also include the change in physical size. Like, if my physical size is big, that means I'm fat, right? If my physical size is small, that means like maybe I'm skinny. So physical also includes size. Okay, then next would be for chemical change, which is chemical reactions. So for chemical reaction is where new substances are formed. Yep, so for new substances, because if you react, wouldn't it be new substances form? Yep, so for new substances form, because maybe I have hydrogen and oxygen, I can react to form water. So you see, from gas, I can form liquid. Isn't the liquid a new substance? Yeah, so that's why chemical change is known as new substance form. As well as the properties will be different. Because for example, like if we look at like water, for example, so water, it would be like hydrogen. Okay, the bracket here, I'm referring to the states, okay? So bracket G means gas, and oxygen, you can form water, correct? Yeah, then for water, it is liquid state. So in this case, can you see that originally is glacial state? At the end is liquid state. So can you see that there's a change in properties? So once there's a change in physical properties or chemical properties, this will be considered a chemical change. Okay? And then you've got new substance form. As well as it is irreversible. So usually once you form, you can't form back the original. If you want to try to force it back, a bit difficult, but might be possible, but depending on the substance. Done. So take note, okay, for this topic, when they ask you explain versus describe, make sure the answer is different. When they ask you to explain, this is how you write your answer. So when they ask you to explain, maybe they give you a reaction, is this a chemical or physical change? And then when they ask you to explain, these are the possible answers to write for explain. But when they ask you to describe, then your answer will be different already. Let's write it down. If they ask you to describe, the possible answers would be, you can mention that, is there any color change? So once you see color change, that means actually new substance is formed. That's why it's a chemical change. Or you might see like effervescence. Effervescence means bubble. So once you see effervescence or bubbles form, then that would be chemical change. Yeah, so I think the effervescence you all know, right? It's like from the topic of acid bases, like acid plus carbonate, you have the effervescence of like the carbon dioxide. Or there might be heat release, or that might be light, like it start to glow. Yeah, so all these are for describe answer, because describe, it will be based on your 5 senses, like your sight, your sense of touch and all. Because can you stop softer a bit? It's very disruptive. Thank you. Okay, so yeah, so take note, okay, when describe or explain, give the correct answer. Yeah, don't write the wrong thing. Done copying, right? I shall move on. Yeah, all these are all for chemical change. Okay, so maybe let me arrow it clearly. So it's for chemical change. Okay, so then moving on. So this topic, as you can see, the name is called chemical change. So the focus would be chemical change. Oh, wait. Let me write down more. Over here, can we write down? The examples would include like boiling, freezing, melting. Hello, are you copying? Yeah, so all these are physical change. The physical size, the physical states. Are you copying? Yeah, make sure you follow and copy it down. Mhm. Haven't confirmed it yet later. Yeah, that's not difficult. Okay, so I shall move on now. So let's focus now on chemical changes, which is the chemical reactions. Okay, so for chemical reaction, you need to know that all the chemical equations are rearrangement of the atoms. Yep, so like for example, like you see, sulfur and oxygen, if you have chemical reaction, they might combine. So you see, you rearrange it such that the oxygen you split up and sort in the sulfur in between. Yeah, so this is word equation, this chemical equation. So for express students, don't need to know chemical equation. Chemical equation not tested. So chemical equations only for IT students. Next, chemical reactions involving the different substances. So there's chemical equation involving heat, chemical equation involving mixing, involving light, involving electricity, involving oxygen. So let's go through one by one, starting off with the first one. So if it's reaction involving heat, it would be combination. So what's combination? Take note, combination, they have a strict rule. It's not anyhow I combine, that's called combination. No, combination has a rule that it must be two or more substance combined to form only one. It means the endpoint must only be one substance. So that means like if I have 5, I combine to 3, it's not combination. It must be 5 become 1. The endpoint must be 1. 4 become 1. 2 become 1 also can. But the endpoint must be 1. So let's write it down. Okay, so it should be 2 or more substances combined into a single product. It has to be single. It has to be only one product. Okay, then next it would be that you see over here, 2 become 1. So it's always from one product. Okay. Okay, then next would be for combustion. Combustion, it would be where you react. Oh, wait. Let me demo to you like examples of combination. Okay, so if I were to, okay, this one, you know, this is definitely a correct example. Let me give you another example. You tell me, do you think is it combination reaction? Okay, so if I were to say that, let me see. If I have like, you know, just now, the hydrogen and oxygen to form water. In this case, do you think is it a combination reaction? So can you nod your head if you think yes or no if you think it's not combination. So how? Is it a combination reaction? So I see some nod head, some shake head. Look online, you can type it in the chat also. Like, do you think is it a combination reaction? Like yes or no? So how? What do you think? Is this a combination reaction? Is this a combination reaction? What does the rest of you think? Yes or no? Is it a combination reaction? How about those online? Do you think it's a combination reaction? Yes or no? So not sure. Okay, I shall review the answer. Okay, so half of you correct. The answer is yes, it's a combination reaction. Why? Because two substances combine to form one. As long as your endpoint is one substance, it's called combination reaction. Okay, so then now maybe if okay, so that means in other words, okay, I write it down in simple terms. So that means if you have many, you combine to form one. This is combination. If you have this, maybe I have P plus Q plus R, I form S and T. Like that is not combination. Because you see, it's 3 become 2. Cannot 2. Your endpoint must be only 1. Okay, so that's combination. So this one cannot, because cannot be 2. Yep. So can only be one substance, one product. Okay, so hopefully this is clearer. Okay, so then next would be, okay, I give you another example. So what if I write this? You know the acid bases topic where I have like acid. Okay, wait, let me think. Do I have a, okay, I can't think offhand of another equation. Never mind, I move on first. Okay, next is combustion. Need to know that combustion is actually means burning. Okay, right now, combustion means burning. Yep, and you need to know that when you burn, we always need one type of gas to burn, right? Which is the gas that we need for burning? Oxygen. Yep. So that's why we can also kind of say that combustion is an oxidation reaction also, because it not only involves heat, it also reacts with oxygen. Yep. So then in this case, you see, you need oxygen for burning, and then you also need the fire to heat it. Next, thermal decomposition. Take note that combination and thermal decomposition, they are directly opposite of each other. Yep. So for decomposition reaction is opposite. So let me write it down. Decomposition reaction would be one, you break down into many. Gus, concentrate and copy it down. So for decomposition is one, you break down into many. Something like, you know, a dead animal or dead leaf, they decompose. Isn't it one animal, you break down into many? Yeah, so that's why it must be one, you break down into many. So if it is like this, so that means if I have like P and Q, I break down into many, R, S, T, U. Why? I break down into many, right? This one, not decomposition. Why? Because this one, you have two substance, which is wrong already, no? So cannot be two. It can only be one. And by the way, the word reactant means starting is called reactant, ending is called product. That's why I use the word reactant product. Right? So take note, okay, be it combination or decomposition, the key point is must always start with one or end with one. So that's why can you see over here only one substance, you break it down into many. Okay, so now let me ask you, how about this? I see carbonate. How about this reaction? Acid plus carbonate. Remember this equation from acid bases topic? You will form the salt, carbon dioxide, and water, right? So in this case, do you think is this a decomposition reaction? So how is it a decomposition reaction? What do you think? Very good. It's not a decomposition reaction. Why? What's the reason for it? Why is it not a decomposition reaction? Very good. There's two of them. So if there's two, then it cannot. Okay, so you must always start with one only. So even though two you break down into many, it is still not decomposition. Yeah? So let's put a cross over here. So it has to only be one. So just remember, either you start with one or you end with one. So let's write it down properly too. So over here, I wrote down like two or more combined into one. So over here, it would be, okay, right on the left side, it would be one single reactant. It will be broken down. Hello, are you copying? Forward and copy down. Yep, so it's always single. Maybe let's highlight the word single also, since the word single is important. Yep, so can you highlight the word single? So either start with one or end with one. So Kyra's question is asking if it's decomposition without the word thermal, then yes, it is still a chemical change because new substances are formed. Oh yeah, it should be a cross. Thanks for highlighting. Oh, people, sorry, I write down the wrong icon. Over here, it should be a cross, sorry. So this is not correct. Because I said mine cannot be two. Sorry, can you change it? It should be a cross. This is not a combination reaction. Have you all amended this? I changed to a cross. Sorry, I write wrongly. Okay, I shall move on. Done copying, right? Okay, so moving on. Next. Okay, so this is chemical reaction involving mixing. So you realize that for mixing, you will have the same number of products. This is quite easy. I'll move on. Next, reaction involving light. I think you all know, right? Like photosynthesis, it involves light. And there's, you see, another decomposition. So take note that decomposition, not only thermal, like what Kyra has asked, there's actually three ways to decompose. So maybe let's write it down at the top over here. So decomposition can be in three main ways. Number one, just now you all saw, right? Thermal. Number 2, which is just shown over here, using light. The third way, it will be actually electricity. So there's 3 ways to break one substance into many simpler substances through decomposition. Okay, so there are 3 methods for decomposition. Write down. Yes?
hydrolysis?
Hydrolysis, yeah, is under electricity. Okay, so let's take a look at the first one for light. So as you can see, from one substance, you break down into many. Can you see? 1 become 2. So as long as you start from 1 and you break down, that's decomposition. So for electricity over here also, so examples can also include like hydrolysis, if your school got cover. If never cover, you don't know what is this, then never mind, you can skip it. Okay, so for electricity, can you see? This is also decomposition using electricity, which is electrolysis. So you see, 1 become many. So you see, again, must always start with 1. Electroplating is using electricity to coat with a layer of another metal. So maybe, for example, if I find that, maybe I very like yellow gold, for example, but I find, yellow gold very expensive. So what I can do is, maybe I can buy a silver necklace, but outside coat with a layer of gold. So this is called gold-plated silver necklace. So people, when they look at me, they thought that, hey, I'm wearing gold necklace, but actually, it's not totally gold. Yeah, inside is like actually silver. Yeah, also that's why electroplating is a way to can lower the cost of the metal, or maybe certain metal structure, you want it to be able to withstand to rust. But then if you use stainless steel for the whole thing, it's very expensive. So maybe inside I can use a cheaper metal, then on the outside I coat with a layer of stainless steel so that the object won't corrode or won't rust easily. Yeah, so that's the purpose of electroplating. It's just to coat with a layer of another metal. Okay, moving on. Next part over here, oxidation. Oxidation, as the name suggests, it just means reaction with oxygen. The oxygen is added. Okay, so you see, as long as we got plus oxygen, that's called oxidation. Highlighted. Hello, have you highlighted it? Yeah, highlight the keywords. Okay, so moving on. Okay, so so this part would be on acid and alkali. So let me see. Is there any question that you can do? Yes, yes. Let's take a look at the MCQ question number 8. MCQ question number 8. Over here, this question. Hello, are you at question number 8? Okay, come, let's read. The following are some reactions that occur in our daily lives. So they have decomposition of silver bromide to become silver, lighting a bulb by passing a current, formation of oxygen in plants using carbon dioxide. So they are asking you which one involve light. So right now, can you cross compare with the notes and see which of the following is under the section of light? Yep, so can you compare with the notes? Light over here. So for the first one, the decomposition of the silver bromide, is it under light? Hello, what do you think? Is statement number 1 correct? Is statement number 1 correct or not? Is statement number 1 correct? Yes, very good. Why? Because it is over here. Can you see? Then light decompose this. Isn't this the exact same one as option number 1? Yeah, so option number 1 is correct. How about option number 2? Do you see over here? And by the way, class, can you all lower your volume, please? Thank you. So for option 2, you don't see it here, right? So option 2 is incorrect. Ready? Okay, so option number 3 is the oxygen in plants. So is option 3 in this section over here in light? Oxygen in plants. Yes, right? Photosynthesis, right? Photosynthesis. Yeah, there's also involving oxygen. Yeah. So formation of oxygen. So that means the first and third statement is correct. Okay, so that's why the answer will be C. Okay. Yep, so answer is C. Okay, so maybe over here you can also write in the page number. So just now it was from page this page here. This is page 12. Yep, so can you write down that can refer to notes page 12? Right now, notes page 12. Write it in. Notes page 12. Hello, have you written it in? Written? I move on. Okay, so moving on to the notes because I haven't finished chemical equations yet. Yep, let's move on to this page. Acids and alkalis. You also need to know that acid tastes sour. So some examples of food that we have acid would be. So how do you know any examples of food that taste sour that have acid? Lemon, orange, vinegar. Yeah, so food that tastes sour, or maybe kimchi. Yeah, so kimchi they actually put in a lot of vinegar. That's why it tastes sour. Next, alkali. Ready? Can I continue on with lesson? Okay, so next would be alkali. Alkali, it would be soapy, because you know, right? Alkali is found in soap. And then if you accidentally eat soap, isn't that like bitter? Yeah, you'll be like, that's very disgusting, right? If you accidentally eat soap. Yep. Okay, then next is need to know that acid and alkali can conduct electricity. Why? Because of the ions present. So can you draw an arrow? So the ions is the one that help you to conduct electricity. Yeah, so all these mobile ions, they can move around, carry the charges. That's why conducting the electricity. Okay, then next would be whether it will damage the skin or not. The answer is yes, because especially when it's concentrated. Yeah, so if it's very strong acid, they will actually burn through the skin. Okay, then next would be the litmus paper. So litmus paper, for acid, it would be red color, while alkali, it will actually cause the litmus paper to turn blue color. So how to remember that like acid is like red, alkali is blue? Actually, not only litmus paper. If you were to look at like universal indicator or any other pH indicators, right, they will also form red color, most of them. Yeah. So how to remember? So usually, my favorite is I like to show some of the shows that I watch. So, hello class, can you all lower your volume, please? Okay, so okay, for me, okay, just to share a little bit more about myself. I really like Korean drama. So usually when I teach this topic, I will always show my student a show that I watched previously, which is the My Demon. Do you all watch My Demon or not?
Oh my god.
Yeah. Okay, so for My Demon, right? There's actually this acid scene. If you never seen before, I will just show it to you again. This one? I can't remember which one is it. Yeah, correct. Yeah, so this is the you know the hero save the beauty kind of scenario. Yeah, so there is this like girl that soon there will be like someone trying to pour acid on her. So take note, okay, acid is very, very dangerous. You take a look at the effect of acid. Yeah, so this motorcyclist is like trying to pour the acid. So you see, he is pouring. Then in the end, what happened? So the 英雄救美, the hero comes and saves the beauty. So in the end, the guy came and shield her. Then you look, wow, it's burning the floor. Then it also burned his skin, you know. Yeah, it's not, I don't know whether you all saw or not. Yeah, it actually burned through his skin earlier. Yeah, so wait, slightly in front. Where is it? Yeah, then can you see it's like it's burning through his clothes and skin. Yeah, then even the floor you can see is like burning. So remember, okay, acid is very, very dangerous. And then usually danger, what's the color that we use to represent danger? Red, right? So that's how you can remember that litmus paper. And then there's this like that dramatic scene. They're like, wow, like the handsome guy saves the girl. Yeah, that kind of thing. Okay, I'll stop you. Yeah, so that's one. Another way to remember is yeah, so this the other one that I usually show to my students is that do you know that in India there's a lot of acid attack? Yeah, so what happens is that like acid is very accessible in India, and then the law is very biased towards the male. That means it's good for the males, bad for the females. That is why do you know that India is actually the country with the highest rape case? Every day there's woman that is being raped. Yeah, it's the law is really like totally not protecting the female. It's like very biased towards the guys. So maybe if the guy were to rape the female, maybe just fine a few $100, but they don't feel the pinch, right? I wish just keep paying law, never mind, right? That kind of thing. Yeah, so then like so like you see, they go and like harm the female. Then in the end, there's not much law against the guy. Maybe just small fine, but they can just like pour acid on the female. Then sometimes they will be like thinking like, okay, they will do it this way, like they will see, oh, how come my wife? How come you talking to your male neighbor? You talking to a guy, must be you too pretty, right? Okay, I spray acid on your face, like that lor. Or why you see the wrong face? Why you see? Why you look at male neighbor? And then I dig out your eyes. That kind of scenario. So you see, it's a lot of yeah. So this is what's happening. So please find yourself please, like, you know how to say, like, you know, like, be contented with life, like that you're actually in a very safe place, like in Singapore. Yeah, where the law is like, you know, keeping everything in place, yeah, protecting you. Yeah, so these are all the cases of all the acid attack. There's a lot, a lot. Yeah, so why am I trying to show you over here? It's also good to be more knowledgeable about things happening elsewhere, as well as, see, acid very dangerous, right? So very dangerous means it is red color. Okay, so remember, acid, it is red color. Okay, so litmus paper, universal indicator, other indicators will always be red color. Next, how to remember that alkaline is blue? You go by this. You know, alkaline is like you use in soap. So whenever you shower, when you come out, don't you feel very cooling after showering? Right? So cool color is blue color, right? Blue is cool color. So that's how you can remember. Okay, so I shall move on. Next part over here is all the chemical reactions. So over here, there are 3 of them. So how to remember? So usually I think school teacher always tell you, okay, class must memorize acid plus metal gas, salt and hydrogen gas. So usually you just have to memorize by heart. But a lot of things to memorize very hard, right? So usually at tuition, how I teach my own class is ways to remember. So how to remember? So there's mnemonics to remember. You can go by this. This one you can go by. Can you see the letter? This is called mash. You know, you mash the potato up, or maybe you mash some music up to make some remix. So mash. M-A form S-H. Okay, mash. M-A form S-H. The second one over here, you can also have a mnemonic called, so water is H, right? So this one is our favorite, cash, right? With cash, you can buy a lot of things. Yeah, you can buy whatever K-pop album you want. You can buy any food that you like to eat. Yeah, so cash. So cash is carbonate plus acid. You form salt and H2O, water. But of course, carbonate definitely will form carbon dioxide, right? That's why plus carbon dioxide. Because the name already got the word carbon. So carbon, obviously, you will form carbon dioxide. Okay, so there's mesh, there's cash. The last one is called bash. You know, you like bash people, bash. Yep. So the one over here is called bash. Let's write it down. So this is the BA form as H2O. Bash. Okay, so mesh, cash, bash. Hopefully it's easier for you to remember. Done copying, right? Yep, so these are ways that I usually use in my lesson to help students remember. Okay, so class, can I have silence please so that I can continue on? Can, so that I don't need to raise my volume until so loud. If not, I'm very tired also. I keep on to talk very loud. Okay, so take note, okay. This part, because it's highlighted in red, but yours is black and white. Can you highlight this red color sentence? Hello, can you highlight this red color sentence? Because yours is black and white. Can you highlight it to make it more outstanding like mine, like that, like red color? Yeah, highlight this red color part. So take note that if your metal is unreactive, they won't react. Okay, so that's why sometimes like question they like to ask you like which of the following maybe like got like maybe effervescence. Then maybe they show you copper plus acid, and then take note copper plus acid don't have effervescence or bubbles. Okay, because they are unreactive. Unreactive means they do not react. Nothing will happen. Ready? Can I continue on the lesson? Yes. They don't use copper with metal. They will use like maybe copper hydroxide with maybe acid, then you form the salt. Yeah, so base plus acid can still form salt. Yeah. Okay, so then so you have to remember, okay, these are the 4 unreactive metals. I would say the first 3 are the more commonly tested ones. Platinum, less tested. Because okay, so how do you remember? So you know, like jewelry making. Usually we will use gold and silver to make jewelry, right? Why? Because like, you see, even for me, I also wearing jewelry and when I wear jewelry, I will be a bit lazy to keep on take in and out when I shower. So usually I'll just wear it to shower. And when you wear it to shower, wouldn't it be exposed to like maybe the soap? And then maybe now if I were to perspire, then perspire also like chemicals, right? So or maybe I put sunblock or what, then there's a lot of chemicals. But I do not want my jewelry to change color. So that's why in this case, you would actually have to make sure that jewelry has to be unreactive. Don't react with soap and any other product. That's why we usually use gold and silver for jewelry making. Copper will be used in electrical wires. You know, like wires like in the wall, like to have the lights over here. my wires, I wouldn't really change it, right? Maybe like a few decades, I wouldn't even change it. So obviously, I need to have a wire that doesn't react. Yeah, so that's why copper is unreactive. So that's how you can remember. Jewelry and copper wires, they have to be unreactive. That's why these three are unreactive. Platinum is one of the more expensive jewelry. So platinum is actually even more expensive than gold because it's even more unreactive than gold. That's why it's even more expensive. Okay, then next part over here. So for this part here, because there is hydrogen gas form, so as long as you have gas, that will be bubble. So the word bubbles means effervescence. So keywords, please spell correctly. So whenever you write about the bubbles, need to include the color and the smell. So if they only ask you for 1 mark, you write this, okay? This is the main observation. If they ask for 2 marks, you then write down more. Okay, then next would be if you need to test, because you know, like there are so many gases, right, that can be colorless and odorless. So how do you know that that gas, like over here, you see got nitrogen gas, got water vapor, got carbon dioxide. How do you know that this colorless gas is hydrogen? So what you need to do is you have to test for gas. So you have to place a lighted splint and make sure that it will extinguish with a pop sound. 1 inverted or 2 inverted doesn't matter. As long as got inverted comma will do. Must have inverted comma. If don't have inverted comma, cannot. Okay, then moving on. Next would be the third one, which is acid plus carbonate, which is our cash. So for cash, it would be you have bubbles again. So that's why the observation would be same thing. Effervescence of colorless and odorless. So you see, if the observation is exactly the same, then how do you distinguish? That's why you need to test for gas. So you need to bubble it through lime water. Lime water, the chemical name is called calcium hydroxide. Then if you see like, now you're not in primary school, so don't use the word cloudy or like chalky, okay? So you use the word white precipitate form. So once there's white precipitate form, it means that the gas is carbon dioxide. Then for the last one, do you realize no gas? So no gas, don't need to write effervescence. Okay, just temperature increase will do. So done for this part. Okay, so let's take a look at questions that is related to all these equations over here. Let's take a look at MCQ question number 10. MCQ question number 10. Are you at this stage? Okay, so for question number 10 over here, which describes class, can you lower our volume, please? Ready? Can I continue? Okay, so you need to know that for this question, they're asking you which describes a positive test to show that an acid has reacted with a metal in a test tube. So to be a positive test means you need to prove that it is present. That's what they meant by positive test. So let's write down. Positive test means need to prove its presence. So how do you prove that a gas is present? So in this case, if it's acid and metal, isn't this the equation? Mesh. Yep, so mesh, it would be MaSH2. So take note, okay, that mesh is the only one that the H is not H2O. So all other, the H is always H2O. Only mesh is H2 instead. There's also H2, it would be the pop sound. So answer will be B. Okay, so I think maybe also let's highlight it inside your notes that for this equation, this is the only one that is hydrogen and not water. So let's label it in. Okay, so let's highlight it. So need to know that the common product is actually salt. Can you see? Salt is the common product. Yeah, so let's write it down. Salt is the only common product. This salt is the only common product. Water is not. Because can you see? The first one don't have water. Only the second and third one got water. But the first one don't have water. Yep, so water is not a common product. Only salt is a common product. Class, have you written this in? Can you write this down? That salt is the only common product for all the reaction. Salt is present throughout, but water isn't. Have you copied? Okay, then for Ignatius, you are asking, does it react with acid that are not dilute? Generally for metal or carbonate, even if it's dilute, can still react, just that the reaction will be slower. Then for burning splint and lighter splint, yes, they are the same thing. Okay, so I shall move on. Okay, so for the mock paper, there are some more questions. Let's take a look at question number 23. Okay, so for question 23 over here, they say that in an experiment, solid calcium carbonate is added into excess dilute hydrochloric acid solution and a gas is given off in the aqueous solution. So for part A, part 1, they're asking you to write the word equation for the reaction. Okay, so if you are in express stream, you write word equation. If you are in IP stream, you write chemical equation. Yep, so let's take a look. So in this case, this is a carbonate, right? And then there's acid. Isn't this our hash equation? And then carbon obviously will form carbon dioxide. Yep, so then you just write it out. Yep, so in this case, what's the answer? So this time around, you need to derive the salt. Okay, so take note, you cannot just write salt, okay? So over here, you cannot just write salt. You need to give the name of the salt. So how do you know what is the name of the salt? Okay, so you go by this way. I think I would prefer to write it in the notes. Okay, so let me go to the notes. Okay, can you go back to the notes? Sorry. Let's come back to the notes here. Okay, so whenever there is a salt, just now we wrote down at the bottom, right, about the salt, that is the only common product, correct? Okay, so then now can you also add on that salt? It has to be also an ionic compound. Write it down. Salt has to be an ionic compound. Okay, if you do not know what's ionic compound, another way to look at it is it must always be either a metal plus non-metal, or it must be a cation and anion. Hello, can you follow and write it down? Just now you wrote down, right, salt is the only common product. Okay, can you add on? So there's two key points. You need to know that salt, cannot just write salt. So salt is metal and non-metal. Done copying? Okay, so then now let's go back to the worksheet. So for just now, that question over here. So in this case, if you want to form your salt, it must be metal and non-metal. So what you need to do is the two substances, they must combine together to form your salt. So what are the two substances that you combine? Must be metal and non-metal. Over here, is there any of them that is metal? So you just check periodic table. Periodic table, zigzag line. The zigzag line, left side, it will be metal. Right side is non-metal. So is there any that is metal over here for calcium carbonate? Which one is the metal? Which one is the metal? Yes. Carbonate. Calcium is a metal, okay? Then since I mentioned that must be metal plus non-metal. Over here, hydrogen, hydrochloric acid means hydrogen and chlorine. So if you check periodic table, both are non-metals, correct? Both are non-metals. That's why in order to form your salt, it must be metal plus non-metal. Since the right side don't have any metal, the only way to have metal is on the left side. Yeah, so that's why you take the metal from the left side and the non-metal on the right side. So that means my salt. What's the chemical formula of my salt? My salt will be metal, which is calcium. And then what's the non-metal? Since calcium is a cation, that means you need an anion, right? So that means you should choose chlorine, because chlorine is an anion, right? Acid always form H plus and Cl minus. That's why the answer, it will be chlorine. But take note, cannot spell as chlorine. When it is the second word, you must spell as chloride instead. So take note that periodic table, although they spell it as chlorine, once you form a salt, it becomes chloride. Something like, you don't call it as we call it as carbon dioxide, correct? We breathe out carbon dioxide. We don't say that we breathe out carbon dioxygen, you get what I mean? So you cannot follow the same spelling in your periodic table. You cannot say carbon dioxygen. So same for here, you cannot say calcium chlorine. You have to say calcium chloride. Like oxygen become oxide, IDE. Chlorine also become IDE, chloride. Yep, so that's why in this case, now you can write out the equation. So for the equation, just copy down calcium carbonate and hydrochloric acid. The word solid, excess, dilute, all these don't need. Yep, so then the answer would be this for the word equation. Then for the IP students who are writing chemical equation, your answer would be this. So for the IP students, remember to balance your chemical equation. Yeah, so need to have the number 2 in front. Yep, then I just go through a little bit for IP students. So for calcium chloride, the salt, how do you know what's the chemical formula? So it go by this. Calcium, you have to check periodic table, is 2 plus. Cl, you check periodic table, is minus. So remember, whenever got metal and non-metal, the technique is you have to use this cross method. So that means I bring down the number without the charge. So I only bring down the number, then done. So that means in other words, you need to have 2 negatives to balance 2 positive. That's why it's 2 chlorines to balance 1 calcium. So that 2 negative balance with 2 positive. Can? Yeah, like that. Yeah, so that's the chemical formula for calcium chloride. So just remember, whenever got metal, you must always use this cross method. Okay, so moving on to the next part, part 2. The gas given off is bubbled into universal indicator, and they say it become yellow. So what is the pH? Oh, I realized because I haven't teach the next page of the notes. Okay, so let me go back to the notes so that I can see the color. You're done copying, right? Okay, I wait for a while. Anyway, if you're not done copying, no worries, because as mentioned, I'll be providing the answer key at the end of the lesson. You can slowly copy down the correction from the answer key. Okay, so I'll be moving on in 3 seconds. 3, 2, 1. Okay, moving on. Okay, so in the notes over here, right? Class, are you ready? If you are ready, can I have silence, please? Because I can feel my throat a bit. Because just now before your class, I was teaching another 3-hour session. So now it's my second 3-hour session. I can feel my throat. The voice going to gone soon. So yeah, I need you all to lower your volume. Then I will need to keep raising my voice. Okay, so over here, this is actually how the universal indicator look like if you were to place it in substances of different pH. Yep. And take note, okay, for all these pH indicators, you should only always add a few drops only. You are not supposed to, wow, got universal indicator, okay, I stand and play with it and add a lot. Cannot. Why? Because the reason is because all the pH indicators are slightly acidic. So they just extra info lah. It's because they are slightly acidic. If you spam too much of the universal indicator, it might actually cause your whole solution's pH to become something else. Then it won't be accurate anymore. Yep. So that's why need to make sure that the indicator you need add in a bit. So as mentioned just now, remember whenever it's acidic, it would be red in color. So by the way, can you write it in? Because I think your worksheet is black and white, right? Let's fill in the colors manually then. So left side is red. Number 4 is orange. Then 5 and 6 is yellow. Hello, are you copying the color? Because yours is black and white, right? But my screen is colored. Can you fill in the color now? Yep. Then for 7 to 10, this would be green. Then here is blue. Then here will be violet. Now fill in the colors. So remember, I told you, see, be it litmus paper or universal indicator, whenever it's a base, it's 2 colors. So 2 colors, it will be blue color. Then acid is like you saw the sound of my demon, that video, very scary, right? Also red color is scary color. Okay, so yeah, danger color. So red is acidic. Okay, then next would be the next part here. So they actually showed you the universal indicator color and litmus color. So based on this information over here, we can now answer the question. So our question was, Where was the question? Over here. So then they said that this time round they bubble it and they say yellow. So yellow is before green. Green is neutral, ma. So yellow means it is slightly acidic. So just slightly below 7. So the range of answers that I will accept is pH 5 or pH 6. 5 or 6 is alright. And if you write pH thing, no, even at the start of the sentence, it's always small letter p, even at the start of the sentence. Okay? So it's pH 5 or pH 6. Both I will accept. Moving on. Next part. So over here, they are saying that there is a graph and show that the mass of the beaker containing the solid calcium carbonate and excess hydrochloric acid. Then you realize that, how come when you measure, you realize the beaker keep getting lighter and lighter and lighter, and explain why. So what do you all think is the answer? Why does it get lighter? Why does the beaker get lighter when you have acid react with carbonate? Or maybe let's think of the equation first. This is carbonate, isn't it? CaS and H. And then carbonate confirm form carbon dioxide, right? Yeah. So in this case, why do you think there is a decrease in mass? Which one? Which product do you think affects the decrease? Yes, very good. Why? Because carbon dioxide is a gas, right? And what happened to the gas? It will escape your surrounding. Yep, correct. That would be the answer. Done. Yep. Then, let's write it in. So the answer would be this. So for those of you who have completed, you can check and see if your answers are correct. So mainly it's because because carbon dioxide is a gas. Do you write that first? And since it is a gas, that's why it is able to escape into the surrounding. Yep, that's why in the end, when you want to measure the mass, which is the electronic balance, you cannot measure it. Done. Actually, if you have these 4 highlighted keywords, I'll give you the mark already. Even if you don't have the bottom part, it's okay. I will still give you the mark. Yeah, but of course, if you want to be more complete, then it will be good to also include the bottom part. Yes? The water was because water at now room temperature, water always exists as liquid state. So the water won't become water vapor. Water will only become water vapor when you reach like boiling point. I mean, you heat it up to evaporate it. Yeah. So only carbon dioxide at room temperature is naturally a gas. That's why carbon dioxide will escape. Okay, so done for this part. Likewise, if you're not done with correction, no worries. I'll be providing you the answer key at the end of the session today. Then you can slowly write in the correction at your own time. So I think now it's just more of like, just check your answer to see if it's correct or not. Good enough. Okay, so continue on. I haven't finished the chapter on acid bases yet. Let me finish it up. Okay, so I was here, right? Then okay, wait. I haven't finished. Okay, so next part over here is, we have a lot of reaction, right? We have like acid, we have salt, we have base. So how would you be able to differentiate? Is it an acid, base, or salt? So to differentiate, okay, if you have space at the bottom over here of page 13, yep, so can you follow and copy it down? Okay, so how do you tell if it's acid, base, or salt? So the way to recognize is acid. Acid usually have the hydrogen ion, right? Because acid always has H plus. So that means if you look at the chemical name, they will have hydrogen. Or if you look at the spelling, they will usually write the word acid. Next, how do you know it's a base? Base is always metal oxide or metal hydroxide. Yes, it's always like that. So that means it's like metal with oxygen. Maybe like I can say maybe magnesium with oxygen or iron with oxygen. That's a base. Or maybe metal with hydroxide. Hydroxide means OH. Yep, so that means like maybe FeOH or CuOH. As long as any metal with hydroxide, that is a base. Then salt, I mentioned just now, it is an ionic compound. But if you don't learn ionic compound, this word, like you don't learn chemical bonding. So for express students, you don't learn, right? Yeah, so then you can go by metal plus non-metal. Or you can go by cation plus anion. I think for express students, you all only learn the center one. The other two at the side is more for IT students. Okay, so now let me test you and see whether can you differentiate between the 3 of them. Okay, so now if I were to say that I start with something very easy, okay? So if I say this cat is got letter T, T means plus. Yeah. Then anion will be negative. Okay, so if I use this name over here, this is very obvious, right? Which category is it under? Acid, base, or salt? This word obviously is acid because of the name acid. Yeah, so this is an acid. So this for chemical name. So I'll add on for IP students. So for IP students need to know chemical formula, right? So maybe if I say this one over here. Okay, so wait, let me just differentiate, okay? If you are in express stream now, you just copy left side will do. If you are in IP stream, you copy both sides, you copy left and right, okay? So then what if I give you this? Then do you know is this acid, base, or salts? Can tell what is this acid, base, or salt for the IP students? Correct. Because of the letter H. So H means it's an acid. Okay. Then next, what if I talk about the one we keep seeing, right? Calcium carbonate. Do you all know calcium carbonate? Which category is it under? Acid, base, or salt? No, it's not a base. Why? Because this carbonate over here is hydroxide or oxide. The spelling different, right? This is oxide, this is hydroxide. This is called carbonate. The spelling is different. So neutral, it will be under salt.
Is it true calcium is metal and carbonate?
Yeah, calcium is a metal. You check periodic table Z9. Carbonate is C and O. C and O, they are all non-metals on the periodic table. Metal plus non-metal. Yeah, or cation plus anion. Because for IP students, you are supposed to memorize, right? That carbonate is CO32 minus mass. So minus anion.
Then calcium is cation.
Calcium is cation. Then for IP students, you'll learn that ion is formed in ionic bonding. So that's why it fulfill all three. Yeah, for lower side, but upper side there are acidic or alkaline side. Okay, so then let's continue on. So what if, okay, let me test another one. What if I were to test you this NaNO3 for the IP students? Then do you all know what category is this under? NaNO3. What's the answer? Acid, base, or salt? Correct, salt. So take note, although you see the oxygen here, you cannot say that it's an oxide because you learn that NO3 got one name, right? What's the name of NO3 called? Nitrate. So that's why you cannot say that, oh, it becomes oxygen. No, no, no. It's called nitrate as a collective group, okay? So that's why it's called nitrate. It's not an oxide. That's why it will be salt. Okay, then next one. What if I ask you this one? See copper hydroxide. Okay, so in this case, for copper hydroxide, what category is it under? Base. Okay, in a way, you can guess. Okay, I'm just giving one each. Okay, but how do you tell? Can you see that this is a metal? Yeah, so this is a metal hydroxide, right? So you see metal hydroxide. So it is a base. Okay, let me tell you another one. What if I ask you this? What category is it under?
Base.
Yeah, base. Because I test acid, salt. Okay, last one is base. Okay, but how do you tell? Can you see that Fe is iron? Iron is a metal. Metal with oxide, isn't it under base? Yeah, so it's a base also. That's how you tell whether is it acid, base, or salt. Okay. Yeah, so surprisingly, carbonate is also a salt. Just fulfill one will do. So another example that doesn't fulfill all three is ammonium something. Like ammonium chloride. Ammonium is not a metal because ammonium is NH4+. So N and H, they are non-metal and non-metal. But yet it can fulfill because it fulfill the behind. Cation and anion. Ammonium salt. So ammonium chloride for IP students, it is still considered as a salt because ammonium is NH4+, must memorize, right? So then chloride, you check periodic table, is like minus. So ammonium something is still considered a salt even though it doesn't have metal. It's just ammonium something. Yeah. So ammonium anything. Ammonium nitrate, ammonium carbonate, ammonium sulfate, ammonium chloride, ammonium iodide, ammonium anything. Yeah. So it's still considered as salt. Alkaline means it's soluble, but because today got express students, so I don't want to cover too much into IP lah. Yeah, so I'll cover it during our normal lesson. Yes.
Then how do you know if the suffix of the salt is H or I? Like
okay. Yeah, that one. Okay, so the spelling, right? If it's okay, that one is chemical equation topic. Wait, let me just go to the contents page. I jump a little bit. So if you go to I think don't have. I think because this is we remove some of the IP stuff. So what happened is that if it's the IDE, I'll just tell you verbally here, is that, where was I? I was here, right? Okay, so if the spelling end off with IDE, it just means it's the ion. So you can just check the charge in periodic table. So that means like, you know, oxide just O2 minus. And then maybe if it's chloride, then Cl minus. So IDE, you just check the charge in periodic table. By the way, over here, this is more for IP students. Then there's also the other one called ATE, right? Carbonate, sulfate, phosphate, all those. Yeah, so all the ATEs, it has oxygen inside. Yeah, so this kind usually you can't check periodic table. This kind you need to memorize the chemical formula. Yeah, which I have some other mnemonics also, but today I'm not covering on that, so I won't go in that.
So what is ionic compound? It's a metal and
Ionic bonding, ionic bonding form ionic compound.
ionic bonding is metal and
Yeah, correct.
Oh,
Cation with anion. Yeah. Okay, so done for this part. Let me see. Is there any more question that is related to acid bases? I've done with 23, right? Oh, question number. Go through question 9 so far. Can you help me to check? Did I go through question number 9? Did I go through question 9? Have I went through this? Haven't now. Okay, come, let's go through. Substance X was added into a. Can I have like silence, please? Okay, so for question number 9, substance X was added into a conical flask. Can I continue? Okay, so they said that substance X was added into a conical flask containing aqueous sodium hydroxide and a few drops of universal indicator. After adding substance X, they realized that the conical flask was blue. But then you add X, it becomes red. And they ask you what is X. Okay, so you do one by one first. When you see blue, blue is cool color, right? So what kind of pH is this? Is it like acidic, neutral, or alkaline? Correct, it's alkaline. Then when it turns green, what kind of pH is this? Yep, correct. This is neutral pH. So you see, before you add, it is an alkaline. Okay, so at the start, before you add, it's alkaline. But after you add, it becomes neutral. So what are you adding? You are adding something that is can be acidic or you can be neutral a bit. Okay, so the neutral is only if they react away with all the acid. So that means it can be either one answer. Class, can I have silence, please? Sorry, because I already know more voice already, yeah, so I need you all to lower your volume a bit. Thank you. Okay, so then in this case, from alkaline to become neutral, most likely X should be either an acid or it can be something neutral. Why? Because if it's something neutral, like for example, a carbonate. Okay, sorry. Actually, no, sorry, you all don't know it, then mine. It's okay. Yeah, so in this case, alkaline. Alkaline can react with nothing. Alkaline can only react with acid, right? So that means this time round, not neutral. There's no reaction called alkaline react with neutral, right? Yeah, so for your lower sex syllabus, upper sex you learn that base can actually react with something neutral called ammonium salt. Yeah, but for lower sex, since they don't cover on that, then it's just based on alkaline and acid will react. That's why in this case, you will choose the acid, then you choose B. So B will be the answer. Okay. Question number 10, I went through already, right? Have I? I went through already. Okay, can. Yes? Yeah, because as long as not oxide or hydroxide, then it will be under salt. Okay, so done for this part here. Let's move on now to the next part. I'm done with the chapter on chemical changes. Let's now move on to the last chapter, which is transport system in living things. Okay, so transport system is on page 25. Hello, page 25. Okay, so for this topic over here, you need to be able to differentiate between diffusion versus osmosis. Okay, so for diffusion, you need to know that it is the movement of any substance. This is the main way to decide. So like if I give you a question, do you know is it diffusion or osmosis? So you base on if it's any substance, it would be diffusion. If it's for water, and it must be strictly only in liquid state only. So if your water is like water vapor, or maybe if your water is like ice, all this not under osmosis. as well as you need to make sure that must have a membrane. It's a must have. So that means, if, for example, I say that I got water, I spill on the table. So if I spill on the table, do you think is it diffusion or osmosis for the water to move from one end to the other end of the table? What do you think? If I spill water, then the water move from one end to the other end. Is it diffusion or osmosis? No, it's convert. It's one of it. So can you choose one? So water, I spill on table, then the water move from one end to the other end. So the answer is diffusion, because as mentioned, you need to fulfill both criteria. So both must be fulfilled. So on the table, do you have any membrane? Don't have any membrane, right? I never put any membrane, I just pour water on table. So if I don't have membrane, but only fulfill the first criteria, it is still not osmosis. You must fulfill both criteria, then it's osmosis. Okay, so spilling water on table is osmosis. Okay, then for diffusion, it will be the rest. Hey, sorry, what am I saying? Spilling water on table is diffusion. Yeah, correct. Anything else will also be diffusion. Like maybe if you have like maybe steam, I know water vapor moving is also considered under diffusion. Okay, then continue on. Next would be need to know that for diffusion, you use the word concentration. As compared to osmosis, you use the word water potential. So take note, okay, there's no such thing called water concentration. Because if you say that maybe a solution is concentrated refers to how much powder there is, ma. But water is not a solid. Water is the liquid. And so that's why I cannot say water concentration. It's more of like, sugar concentration or salt concentration. So concentration is for the solid, not for the water. So water, we use water potential. So if it's high water potential, means they got more water. Low water potential means less water. Yep, and then take note that both of them, because they always move from high to low, that's why they don't need energy. Just like in the playground slide, if you slide from the top to the bottom of the playground slide, high to low, you don't need energy. Unless you climb against the playground, you climb upward, then that kind need energy. So the opposite is called active transport, but active transport only covered in like very little IP stuff. So I wouldn't be covering. Okay, so I shall move on. Done with all the annotations. Okay, so for water potential, it refers to how much water there is. Okay, so maybe, okay, let me just draw a triangle. Okay, so if I were to have, maybe this side a lot of powder, okay, so this side is like a lot of powder. So a lot of powder versus the other side, little powder. So in this case, if we were to say that you have a lot of powder, it is also known to be higher concentration because it's very concentrated, right? As compared to the right side, it will be lower concentration. But now, if I have a lot of powder, how much water do I have? Do I have a lot of water or a little bit of water? I will have very little water, right? So if I have very little water, it's also known as low water potential. So that's why high concentration is known as low water potential. Then compared to the right side, if I only got a little bit of powder, that means I got a lot of water, correct? That's why the right side, it will be called high water potential. Can better understand now? Okay. Can you follow and copy this in? Hello, are you done copying? Can I move on? Okay, so I shall move on. Okay, so for the next part, okay, so take note, okay, that for water always move from high to low water. Particles always move from high to low concentration of the particles. Similar to us humans, like for example, if you're on the MRT train, if one cabin is high concentration of human, the other cabin low concentration of human, what happens? We will always move from the high to the low concentration side, right? Yeah, so same for particles, so they will move to the less crowded side, so they're not so squeezy. Okay, so then moving on to the next part here, examples that involve diffusion and osmosis, there is the whisking tubing. So need to know that for the whisking tubing, it is partially permeable. That's why, let's write down. Yeah, since it's partially permeable, it will only allow the smaller particles to pass through. Yeah, so large one cannot pass through. Only small one then can diffuse. So you need to know that whenever they say starch solution, you need to know that there is both starch and solution. Solution means it contains what thing? Water, correct. So if you have starch and water, you need to know what can pass through and what cannot. So let me now over here, let me tell you whether the permeability, whether can pass through or not. Okay, so let's write down. So, cause you need to know the common sizes of the particles that can pass through and cannot pass through. So for water, do you think can water pass through partially permeable membrane?
Yeah.
Yep, can. Okay, then next is we look at sugars like starch. Do you think starch can pass through? Starch cannot pass through, huh? Another sugar is called glucose. Do you think glucose can pass through? You know what's glucose? You digest starch to form glucose, right? Remember your digestive system? Yeah, so the carbohydrates, your starch, you digest it into the smaller size called glucose. So glucose can pass through because glucose is digested from, it's very small already. Because it's digested, that's why it is small. So small can pass through. Next, let's go through all the food type, okay? So besides carbohydrates, we also eat proteins, right? So protein is like the original meat that you eat, ma. So protein is like haven't digested yet. So do you think protein can pass through? I cannot pass through. Then the digested form of protein is called amino acids. So amino acids, yes, can pass through because digested. That's why it is small enough. Are you copying? Follow and copy down. Okay, then next we also have okay, they seldom use fats because fats very oily. Okay, the more common examples would be like iodine. Do you all think iodine can pass through the partially permeable membrane? Do you all know? Can or cannot?
Can.
Can, very good. And the last one that they like to test is like ink. You know, like blue ink or blue dye. Yep. So do you think dye or ink can pass through or not? I can also. Yeah, that's why you realize like you know like the plant part sometimes like the stem like or the xylem, yeah, it will become blue because can pass through. Yeah, so these are the common ones that you should know lor. Oh yeah, wait, there's some more. Salt. Yeah, so salt can pass through. If they say sugar, be careful. Sugar depends. Because sugar got different size. So if they say sugar solution, try to think of water passing through. Okay, because the sugar you do not know which size. Is it big or small? That's why if it's sugar solution, just take it as water passing through. Okay, because you do not know the size of sugar. Next, what if it's a salt solution? Then, oh no, salt can pass through. Water also can pass through. So in the end, should you be talking about diffusion of salt or should you be talking about osmosis of sugar or osmosis of water? Which one do you think? If it's a salt solution, should we be talking about movement of the salt or movement of the water? Do you all know? Water, correct. Why? Because you need to know that factors affecting diffusion would be, one of it is mass, which you all learned before in chemistry last year, Sec 1, particulate nature of matter. So in particulate nature of matter, we have learned that mass is one of the factor affecting diffusion. So if you compare salt, okay, so salt solution, right, means it's made up of NaCl. You know the salt that we use for cooking, eating is like sodium chloride, right? Solution is water, H2O. If you go and check the periodic table for the mass, sodium, right, the mass is actually, you check periodic table, the bottom number, sodium is 23. Chlorine is 35.5. If you press the calculator, this is like what, 58.5. As compared to water, the mass is 2 of hydrogen plus oxygen. You check periodic table, oxygen is 16. This is 18. So can you see that the salt is much heavier than water? So if salt is heavier, that means salt would diffuse slower. So if they diffuse slower, we would focus on the movement of water because the lighter one will move faster. Yeah, so that's why in this case, water, we would say that it will move by osmosis faster. And by the way, take note, osmosis is just osmosis. There's no other variation of osmosis. Don't say, oh, this one is diffuse slower, so I osmose faster. No such thing, okay? Yeah, so don't anyhow change the spelling to become SE like diffusion. So there's no such a word called osmose, only osmosis. Osmosis is the only word. Yeah, so that's why if it's a salt solution, the answer is, it should be diffusion or osmosis? Osmosis, okay? Osmosis of water for salt solution. Clear? So maybe we can write it down somewhere. So if it's salt solution or sugar solution, It's always osmosis question. Write down. If it's salt solution or sugar solution, it's always an osmosis question, not diffusion. Copy it. The one on top here. Copy it down. Okay, so I shall move on. Should we done copying? Correct. So if it's salt solution or sugar solution, just take it as water pass through only. Yeah. Okay, so moving on. So that's why for this question here, the iodine we said that can pass through, right? That's why the iodine will go in. Come, let's draw the arrow. Iodine can go in. So iodine go in, that's why inside become blue-black. But outside, not blue-black. So this one is only inside the visking tubing. Hello, can you help me to add it in? So this only happens inside the visking tubing. Outside won't be blue-black, okay? So let's label clearly. Inside is blue-black. What's the color on the outside? Not clear lah. Iodine, what's the original color?
Brown.
Brown, correct. Or yellowish brown also can. Can so need to know. Outside is brown color. Copy. Done copying. I move on. Have you labeled? Blue, black inside, brown outside. Label. Okay, moving on. Okay, so then for the next part over here, so if question were to ask you in terms to explain your answer, so you remember my teaching style, my teaching style I always like to give template. Because you just study a template, you copy paste in the exam, you can score. So it's actually like about how hardworking you are. So usually for my Sec 2 students, like you can see one, like the students that are hardworking, you can see good improvement because I always give you this kind of like answering techniques. You study, you score. Yeah, so it's like how hardworking you are. So the key points would be, first point, you always do comparison first. You compare which side has higher or lower concentration or water potential. After you're done with comparison, next point you talk about would be the movement. How they move from where to where. Then the third point, it would be what happened to the cells. So you describe the changes. Yep, so like the cell become what happened. Yep, so mainly need to cover 3 key points. So if you find memorizing maybe not a thing for you, it's okay. You just go by the 3 points, or as long as you cover all 3 points, will do lah. Yep. Done with all the annotations, right? Okay, but what if both sides have the same water potential or concentration? If both sides is the same, you use the second one. Can you see? The second one is where there is no diffusion. Okay, so I write down clearly for you. You use the first one when there is diffusion. You use the second one when don't have diffusion. Same for the below also. You use the first one when got osmosis. You use the second one when don't have osmosis. Yeah, so when both sides same concentration or water potential gradient, then won't have diffusion or osmosis. Done annotating? Yeah, I move on in 3 seconds. Yeah, so follow and copy it down. Okay, moving on in 3 seconds. 3, 2, 1. Okay, I move on then. Okay, so moving on to the next part. Over here, do you realize I got this part, describe cell? So what are you supposed to fill in the blank? You're supposed to fill in the blank according to over here. So it depends. If the substance enter animal cell, you write cell efforts. If the substance come out of the animal cell, you write shrink and cremated. If the substance go into plant cell, you write turgid. If the substance leave the plant cell, you use plasmolyze. Okay? Yeah. Okay, then I shall move on. Okay, by the way, what's plasmolyze? Plasmolyze means the cell membrane don't touch the cell wall anymore. So take note, cell wall is this thing. Can you see? Cell wall is a layer. Hello, are you listening? Cell wall, can you see, is a layer. Okay, cell membrane is here. Can you see this line? This line is the cell membrane. Can you differentiate? Cell wall versus cell membrane. Then need to take note that once your cell membrane shrink, this hollow space over here is not vacuum. This hollow space here is a solution from your surrounding. That means if it's salt solution, it will be salt solution. If it's sugar solution, then it will be sugar solution. Why? Because you need to know that the cell wall, based on what you learned in Sec 1, it is fully permeable. If it's fully permeable, obviously the liquid can enter, right? That's why the solution can enter the cell wall, but it can't pass through into the cell membrane. So you just stop at the border of cell membrane. Yeah, because it can't pass through the cell membrane. When the substances leave the cell. Yeah, then if you soak in surrounding solution, the surrounding solution will come into this gap. Done. Okay, so I shall move on. Next part over here, need to know the transport in both plants and animals. So for plants, there is xylem and phloem. This one, I think you already know what it is from primary school. I will skip. You study on your own. Then all this you just read through on your own. Nothing much, it's very easy. I go on to animal. Animal a bit more complicated. Okay, so for animals, need to know that for the transport system, there are 4 substances that is transported in the human circulatory system. So for red blood cell, it will transport oxygen. For plasma, it will transport all except oxygen. So now, Clark, I have a question for you. You know, we can breathe in oxygen, breathe out carbon dioxide, right? So for carbon dioxide, where is carbon dioxide transported in? So we've got 4 options, A, B, C, D. So the answer is plasma, correct. So need to know, okay, that plasma is transporting carbon dioxide. Okay, then next, maybe a link to another chapter that you all have learned recently in school. The human reproductive system. So, you know, human reproductive system, we say that the male and female sex organ, which is the ovary and the testis, produce the sex hormones, right? So where would sex hormones be transported at? Where would sex hormones be transported? Do you know? You look at the list. Hormones, where would hormones be transported? Plasma, because plasma transport everything except oxygen. So take note, okay, so it transports hormones also. That is also why we said that, like, maybe if a lady undergo tubal ligation or maybe a male undergo vasectomy, he would become like the guy would become like girly because vasectomy only stops the sperm from traveling, but the hormones can still travel in the blood. Okay, so everything else. So maybe if you have any other waste product, even nutrients, nutrients is also transported in the plasma. Have you copied? Okay, then next, white blood cell. White blood cell is just part of your immune system. Yeah, so to help you to fight infections. And then platelet is just to clot blood to minimize blood loss. Plus, you also prevent the entry of foreign particles so that, you know, bacteria or germs won't enter, then won't cause like inflammation or like maybe like the skin rotting or what. Yeah, so it's like to protect you. So you need the platelets to clot blood. Done. Okay, so I shall move on. Done copying, right? Okay, then next part over here, need to know the 3 different blood vessels. So need to know between the 3 blood vessels. So take note, okay, that for the artery is that usually something, you know, class ready. Can I continue? So like sometimes, you know, they have those MCQ questions, you know, option 1, 2, 3, 4. Then which of the following is true? So now I ask you one question. If I were to ask you, arteries always transport oxygen. Is this true? Does arteries always transport oxygen? The answer is no. So take note, okay? How to remember what's artery? You go by this. You see, A for artery, A for carry blood away from the heart. Okay? So usually I'll write it like that. Artery, it will be away from the heart. Okay? Yep. So not all artery are oxygenated. I would say most are oxygenated, but there are 2 exceptions. The 2 exceptions will be, one is with the lungs one, it's called the pulmonary artery, and one is if the lady is pregnant, which is in the umbilical cord. Yeah, so those 2 are the only exceptions. So not all artery transport oxygen. Okay. So I would say most are oxygenated except 2. So just be careful. So artery confirm. This is confirm. All artery guarantee plus chalk carry blood away from the heart. Okay, then next for vein. Can you see the vein got the letter IN? So IN means go in. It will go into the heart. So most veins are deoxygenated, but except 2 again. The 2 are the one which is connected to our lungs and the umbilical cord. And then for capillary, it's actually very, very small, so they can reach out to the cells and tissues in the organ. Yeah, to transport all the materials that you need, like to transport the useful substances into the cell and carry out, remove the waste substances from the cells. Okay, then, yes.
That way to like tell the difference, like the diagrams between an artery and
Yes, can. Okay, so which would be this part which I'm going through next. So the muscular walls. Last, ready? Okay, so for the artery, you need to take note that it has a very thick wall as compared to the lumen. So take note, okay? You cannot just, hello, can you listen up? So take note, you cannot just see the size big or small. Cannot. It must be a comparison between both. It must be the thickness of the muscle versus the lumen. You must compare both ways. Why? For example, if I were to say that I look at the, hello, can you listen up? If I were to say that if I look at the vein of my pinky versus if I look at the artery in my heart. Do you realize heart need to pump blood to all parts of body? Obviously, the blood vessel in the heart is very big, right? So do you know that the blood vessel that is pumping blood out of the heart is actually the size of the old 50-cent coin in Singapore? It's very big. It's bigger than the current 50-cent coin. Yeah, so imagine if my artery is so big, then if you compare to the vein of my pinky is so narrow, right? Very small. Wouldn't the lumen of my pinky be smaller than the lumen of the artery? Do you agree? Because my blood vessel for the artery is so big, obviously my lumen is bigger. That's why you cannot just say that, oh, lumen bigger means vein. Lumen smaller means artery. No, because the lumen of the artery, which is a big blood vessel, it will be bigger than the vein in my tiny pinky, because my pinky is very small. Okay, so that's why I cannot just look at lumen size. It must be a comparison. You must compare both the muscle layer and the lumen. Okay. Between, so it means this and this, you compare these two. That means lumen versus muscle. So you must see the proportion. Yeah. So if it's around the same, that means the muscle is very thick, then it's artery. If it's very drastically different, the lumen versus the thickness of the walls, then this would be vein. No, this one just usually like if they give you diagram, you can recognize, then good enough. Yeah, so they don't need you to explain it out. Okay, then next for capillary. Capillary is very iconic. Can you see that it's actually one cell? Can you see that there's a nucleus, the cell membrane, and the cytoplasm? So that's why capillary is very obvious. Like, it's just made out of one cell. Yeah. Okay, so moving on. Okay, so then next part over here, need to know the movement of substances. Ready? Okay, so in this case, you need to know that the diagram, what's going on. So you need to know that first, this is actually the cell. Surrounding it is called tissue fluid because many cells together form the tissue, right? And then the fluid around the tissue is called tissue fluid. So you need to know that substances are actually exchanged through diffusion. Yeah, so you need to know that the useful substances will go into the cell. The waste product will come out of the cell. So that's why then they mentioned it over here. Then can you see the arrows? Waste substances go out. So that's why P will be the waste substances, Q and R also waste. So Q, it will be waste substances. R is coming in, S coming in. So R and S would be the useful substances. Yeah. Okay, then there's also diffusion happening in the air sacs in our lungs. So air sacs is also known as the alveolus. So likewise, if your blood is coming towards the lung, likely this would be the deoxygenated blood, correct? Because if you come to the lungs, means I need to like refill oxygen. Yeah, so if you want to refill oxygen, obviously this is deoxygenated. That means your carbon dioxide need to go to the air sacs of the lung, as well as oxygen need to go in. Make sense? Because deoxygenated. So substances will always move from high to low. So deoxygenated means rich in carbon dioxide, poor in oxygen. So yeah, substances always diffuse from high to low concentration. That's why they diffuse this way. Then towards the end, it should be oxygenated blood. So towards the back, if it's oxygenated blood, that means it would be, because the oxygen went in. That's why now it's a lot of oxygen. Then carbon dioxide come out. That's why towards the back, all the carbon dioxide escape. Cannot all, I mean majority. So all this happen through diffusion. Because remember, osmosis is only liquid water. That's why diffusion will be for all other substances. Yeah, so whatever that I just mentioned in words are all in paragraph over here. You can slowly go and read it on your own at home. And then done.
Right?
Yeah, this is in the lung. So this is the air sacs in the lung. Yeah, so maybe let's label it clearly in case you're not sure. So this is happening in the lung, the air sacs. Air sacs also known as alveolus. Alveolus is singular. Alveoli, it would be plural. Done copying? Okay, I'm moving on already. You all should be done copying by now, right? Okay, can wait for a while. Quick, quick, quick. Copy it down, then I can move on. Okay, let's take a look at the mock exam question related to this topic. Can we take a look at question number 16 of the MCQ? 16 and 17. Yep, can you flip to question 16 and 17 now? Okay, I'm moving on in 3 seconds. 3, 2, 1. Okay, moving on. Okay, so question number 16 is over here. Oh yeah, by the way, there is a bit of an error. I think you can tell, right? Here should be higher or lower, but it's okay. You can still do it, right? So what answer did you all get for this question? What's the answer for this question? A. Yes, correct. Very good. By the way, can you just help me to amend it? By right, it should be one side higher, one side lower. Yeah, but okay, can still do it. So answer is A. Yep, so with the typo error, can still do. Yeah, can you help me just do the opposite from the left side? Hello, can you help me to amend the typo error, please? Thank you. Yeah, so answer is A. Because substances always diffuse from high to low concentration. So since they show you that based on the diagram above, is coming out, that means inside would be higher concentration. And for all substances, it would be diffusion. Only liquid water with partially permeable membrane, then is osmosis. Okay, moving on to question number 17. The answer is, what's your answer? C, correct, very good. Yeah, because you need to know that xylem is on the inside, phloem is on the outside. Okay, xylem inside, phloem outside. So since this time round, you are transporting water, because ink it should be in the xylem. Yep, that's why it should be the xylem that becomes ink. Okay, then let's move on to question number 18. What's your answer for question 18? What's your answer for question 18? Yep, correct answer is D. So remember, I told you that it's always based on A for artery, A for away from the heart. Yeah, so that's why if you can see the arrow, this away, right? Then this also away. So away means arterial. Then for the vein, it will be VEIN. So vein means into the heart. Can you see the arrow here is pointing into, then here also pointing into. So that's why 1 and 3 would be vein. Okay, you go by in and just follow the mnemonics here. Okay, then next let's take a look at the open-ended question 27. Open-ended question 27. Okay, so for question 27, isn't it the same diagram from the notes? Yeah, so you can actually refer over there to derive the answer. Okay, so I shall flash the answer to let you check whether did you get the correct answer. Yep, so in this case, name the process. Remember, all other substances, as long as not liquid water, it will be diffusion. Then next is describe and explain the movement. So you can actually just copy the answering technique for diffusion. Yeah, so I write down over here. So can you copy down the diffusion answering technique? People, can you write down the annotation? The answer, no urgent, because I told you, right? I will give you the answer key at the end of the lesson. Can you write down the annotations here? So remember, okay, this topic and the thermal energy topic also. Whenever explain, must use the answering technique. Okay, so must use the answering technique. So first point, remember, is always about the comparison. Then second point, you talk about the movement. Then the third point is like the conclusion. But this time around don't need only 1 mark. So just first 2 points will do. Okay. Have you written the word answering technique? If you haven't do this question, I'll recommend that you go home, you use the answering technique, you give it a try. And then see whether you can write it out on your own. Then you can check the answer. Of course, I'll be giving you the answer key. Oops, sorry. Let me remove this. Okay. Okay, so due to time constraint, I think I will continue on with lesson. If you are not done, can you just copy from the answer key which I'll be providing you? Okay. Yep. So let's now check through your MCQ answers. Okay, come. Let's check through your MCQ answer. I will show the first 10 first. You mark your paper first. Then for those of you who are unaware that you need to finish up the mock exam before coming, can you just maybe shade on the OAS sheet first? So after you shade in front, you can use your own time, at home to do the question behind. Then you just flip back to the OAS sheet in front to take it as like an answer key. You just go at OAS, is it? Okay, then I think you just look here and then you mark accordingly. I think they missed out inserting the OAS sheet. Okay, I scroll down, done right for first 10? Okay, not yet. Okay, I wait. Okay, I scroll down further to the last 10. Can you check your answer? By the way, it seems like I think I will overrun by maybe about like 15 minutes. So if any of your parents are fetching you downstairs, maybe you have to let them know that like maybe you should find somewhere to like wait first. Yeah, so I think I will likely end at like 4:45, I think. Yeah, because I need to finish the mock exam paper. And no choice. Our time is so short, only 3 hours, but so many things I need to go through with you. Because end of year there's so much stuff. Yeah, so yeah, we'll overrun a bit. Okay, so should be done marking by now. Yeah, I'm moving on in 5 seconds. You're not done, then quickly take a photo. 5, 4, 3, 2, 1. Okay, moving on. Okay, so I will go through page by page. Okay, so for the first page, any of you need me to go through any question on the first page? Any question to go through on the first page? Question 2, okay. Question 3, okay, can. I'll go through question 2 and 3. So question 2 over here, they said that a force was applied to hammer a nail into the wall, and the sharp end has this area, and the pressure is exerted like that. So they ask you what is the force. So this one, you need to use the pressure equals to force over area formula. Yep, so for pressure, it would be this value, 300,000. Then force, unknown. Area, it would be this value. So that's why for the force, you just need to multiply them together, will do. Okay? Yep, like that. So by right, this one should give you 150 lah, if you press the calculator. Moving on to question number 3. So question number 3, they said that a bicycle wheel is moving to the right as shown. Okay, so that means in this case, you have the bicycle wheel moving, right? That means there is a force exerted. That means in other words, my force exerted, it will be in this direction. And you know that for friction, it always opposes motion, right? So that's why friction should be in the opposite direction. So friction should be pointing to the right instead. Okay? Anyways, take note that if your school taught you about this free moving wheel versus engine powered wheel, take note that this one would be considered as engine powered wheel. The reason is because for a bicycle wheel, like example, any bicycle I put on the floor, the bicycle wheel won't rotate, right? So why will bicycle wheel rotate? It's because I pedal it. Yeah, so that means you exert a force. That means there's an engine. So the engine is my feet, my legs. So my legs is pedaling it. Oh yeah, go ahead. So then, yeah, so that's why in this case, if you have a force, pedaling force, friction opposes motion, that's why answer is B. Okay, then you need question 1 also. Let me go back to question 1. So question number 1 over here, whenever they ask you for the possible combination, you choose the extreme end. So that means if you go by directly opposite, like 3 Newton and 4 Newton, this would be the minimum force, which is 1 Newton to the right. And then if you were to do it both same direction, this isn't it the maximum force? So the maximum force, it would be 7 Newton. That means your answer can only be from 1 Newton to 7 Newton. So any answer that is not within this range cannot be the answer. That's why 8 is outside this range. 8 would be the answer. So if you have any answers that's in between, it's likely the lines are like diagonals, are like slanted kind. Yes. Okay, so moving on to the next page. For this page, any questions to go through? For this page, any question to go through? If all correct, that's a good sign. Correct? Okay, then I move on. How about question 6, this page? Yeah, I went through, right? Okay, then move on. Question 8, this page I also went through, right? Then question 11, wait, are we on? Yeah, okay. So question 11, this page. Any question to go through? 11, okay. So for question number 11 on ecosystem, so you need to know that whenever you see these two graphs, right, just to ask you all, usually when we have prey and predator, which one is in larger population size? Prey, right? Because you need to have enough food for the predator to feed on, right? So usually there's only a few wolves, but many deers and zebras. Yeah, then maybe you will only have a few cows, but a lot of grass. So usually the lower the trophic level, the larger the population size. Then disease, I think you all know lah. Disease definitely it should cause a decrease or yeah. So that's why it's just between A or B lah. Then you choose B lor. Right? Effect of the disease on the population of predators. But now you should choose the graph of the predator mah. Because they're asking you the graph of the predator. You don't choose on top already. You choose the below. Then disease is decreased. Good that you're enlightened. Okay, so this page done, right? Okay, moving on to the next page. Question 13, this page. Any questions to go through? Any question to go through? Oh, wait, let me go back to question 10. Question 10, you are asking option D, why is it wrong? Lime water remain colorless. No, if you have carbon dioxide, lime water will become like chalky or milky, which is a white precipitate. So it cannot remain colorless. Okay, question 13, this page. Which question to go through? 12, is it? Okay. Okay, class, can I have silence, please? Thank you. My throat a bit strained already. Thank you. Okay, so for question number 12, they are asking you which of the following statement below is incorrect. Okay, so this is an electricity question. Okay, so in this case, they are saying that if one bulb is removed, the voltmeter reading will change. Okay, so let's take a look. If one bulb is removed, so you all know that like when you connect bulbs in parallel, the more the like bulbs in parallel, then it would affect the resistance, right? Because all objects have resistance. So it would become the lower the resistance. So take note, parallel, it has an opposite relationship. More bulk, yet lower resistance. Okay, so take note. So parallel is a bit different from series. Series is the more bulk you have, the more the resistance. But parallel is opposite relationship instead. So that's why now, if you were to have lower resistance, then let's take a look at which one is incorrect. So in this case, for the bulb is removed, ammeter reading will change too, because once you change the resistance, yeah, so once you change the resistance, you would increase the current, right? Because not much opposing resistance, current can flow. So that's why the ammeter reading will change. This is correct. In fact, it will actually increase. Next, if one bulb is removed, the other bulb is light up. Yeah, correct, because parallel arrangement. So this is true. Next, if one bulb is removed, the voltmeter reading will change. Okay, so now you need to know that for volts, this time round, the voltmeter is supplying to the bulbs over here. And that I do not know whether you all learned this. This is I think a bit more towards IP side already. Is that for both, it will actually don't split in parallel. Yeah, so because this is more for IP lah. Because V don't split in parallel. Yeah, so that's why in this case, whether got one or got two, it's still the same answer. Yeah, so that means this part here is still the dry cells voltage. Yeah, so that's why this time round it will not change. Okay, but even if you are in express school, you can still do it because you can look at the other options. If one cell is removed, both bulbs is dimmer. Yeah, so cell meaning dry cell. So of course, if you have less battery, of course your bulb is dimmer, right? So MCQ can go by elimination, ma. So even express students, you can also do it. Because the rest are correct, then C will be incorrect. Done. Okay, right? Okay, so then I shall move on. Done with the annotations, right? Okay, so for question 13 this page, any questions that you all need me to go through? 14, okay. So for 14, they say that when feces stay in the rectum for a long time, they become very hard. And which statement is correct? So this is from digestive system. So you need to know that water is absorbed from the contents in the large intestine. This is true because rectum is also linked to the large intestine. So you need to know that large intestine, there are like a few sections, right? Large intestine, there is like one part called colon. There's also one part called like rectum. Yeah, so if you stay in the large intestine for too long and water is gone, you'll be very hard. Because hard means like dry, dry. So for the first one, digestion of mineral salts. Take note, mineral salts are not digested. Mineral salts are small enough to be digested. Small enough to be absorbed already. So it won't be digested. Won't need to digest. They're called small enough. So the statement itself is incorrect. Next, bacteria present in the large intestine use large amounts of water. Bacteria don't drink water lah. No lah, bacteria don't have mouth to drink water, no lah. They don't really use this. So it's not correct. This one is just this one is more like constipation. So constipation is where too dry, then the poop cannot come out. Then next part, only evaporation takes place where your large intestine is enclosed area. How to have evaporation? No lah, not possible in enclosed area. Yep, so that's why D is not possible. So any more question to go through for this page? All good? Okay, so I shall move on. By the way, just to let you all know, the answer key that I'm giving you don't have the written explanation, okay? The answer key only got A, B, C, D. So if you need all this written explanation, you should copy them down. Okay, so I shall move on. Okay, so for the next page over here, this one I went through just now, right? Then next page I also... Okay, so anyone need me to go through 19 or 20? 19 or 20, need to go through? Oh, good. Okay, that's good. Okay, come. Then let's go through the open-ended now. Okay, so for question number 21 over here, come check your answers. So can you check whether you have all the underlined keywords? Just to tell you, this is actually also an answering technique. So whenever it is, a lot of chapters got answering technique. That's why I find that Sec 2 science very easy to improve. Yeah, it's because first you must always talk about the area. Yep, so you must tell me that it has larger area. Then after that, you mentioned about the pressure exerted by who on who. So better to write it as pressure exerted by Jane lah. I give you one first. Then next is it would be preventing Jane from then just answer back the question or prevent her from sinking into the snow. Why? There's no mention of snow. Oh, okay, then I think don't need the behind part. Yeah.
Yeah, I also thought about like
more comfortable. Not really. Wait, is it comfortable? Can also like because the feet has less pressure, so it is more comfortable. Can, so on this part I will accept more comfortable. Yeah, can.
wait, so the her feet on the ground.
No, she's like wearing the shoe, then the shoe step on the ground. Yeah. So if you only have the front part of your feet touching the ground, then a lot of pressure on the front part of your feet. So the front part is very painful. Yeah, so if the whole feet is down, then it will be less painful. Surface area can. Surface area can. The calculation, okay, right? Anyone need me to explain to you how to derive all these numbers? Anyone need me to explain for the second part? The calculation? No need? Okay, then I shall move on. As mentioned, I will provide you the answer key. You can slowly copy the correction at your own time at home, okay? So I'll move on. Next part here is on the work done formula. So work done is force times distance. So just multiply these two together. Do you have the units, class? Can you check? Units. Do you have the units? Yep, check. Units, are they present? Okay, so moving on to the next question. This one I went through just now, right? Then we move on. This one also went through. Here, ecosystem 24. People. Food chain should always start with animal or plant. Food chain, should we start with animal or plant? Plant, right? So you must have this. Zooplankton, they really say zoo. Zoo is what? Animal, right? Not plant. So that's why zoo is animal. So you cannot start with animal. Must start with plant. So can you write down over here to remind yourself that food chain must start with plants. So even though they never tell you zooplankton feed on algae, you must still start with plants. Okay, so food chain must always start with plants. Have you all copied this in? Hello, write this in. Can you all copy this down? Okay, so must have this arrow, because must link from plants. Okay, then part A, I think should be okay. Quite easy, right? Your answer is wrong, no? I mentioned must start with plant. Can you see the highlighting? Can you write this statement in since you missed it out? Okay, so must have the arrow here. Okay, so moving on. Next would be the definition. You guys should be okay. Like, just check school notes or you check my notes also can. Yep, then mutualistic relationship means, you know, like example, if you say, let's come to a mutual agreement. Mutual agreement means both of us agree because both of us will benefit, right? Because if both of us won't benefit, then why would we be even in an agreement? We won't even have this agreement. Yeah, so mutual agreement means or mutualism, it means both sides benefit. As long as got the word both benefit, I'll take it as correct. So then you just need to mention about the substance. Do you mention the substance? The substance is carbon dioxide or oxygen. Then write out correctly lah. So sea corals is produce carbon dioxide. Then algae is like produce oxygen. Then during what process? Yep, like that lor. Because for corals are actually animals under the animal kingdom. Then for algae is a plant. So just based on animal, respire, plant, photosynthesize. Yeah, I need to know that algae is a animal. Yeah, need to know. Okay, so I shall move on. You're done copying, right? Okay, so then moving on to the next one, question 25. Here's the answer. Is it okay? So remember, N meter is always connected in series, voltmeter connected in parallel. So parallel means it's a separate branch. It's the part C that says draw voltmeter. Part C. Must read all parts of question. Then can you see voltmeter? Must answer all parts of question. Have to be careful. They say using your answer in B, so just draw in B, lor. Just draw in B.
Right? You just say like connect the positive with positive.
No, usually, wait. It's correct that N meter should be positive with positive, negative with negative. So in that case, can lah. I think, yeah, can. I will accept. Yeah, can. Oh, Jenny is asking, the question doesn't say zooplankton consumes algae. But the thing is, based on your knowledge and ecosystem, food chain and food web must start with plants. That is why you have to link it back, even though the question doesn't say. Because if you just directly start from zooplankton, your food chain and food web starting from animal, which is incorrect. That is for variable resistor. So fixed resistor don't have a diagonal arrow. Yeah. Okay, so I think should be done. I move on to the next page, okay? Anyways, no worries, you're not done. The answer key will be provided to you. You can slowly write in your correction. So Ignatius is saying that is it herbivore? Doesn't matter whether it's a herbivore or not. You just need to make sure that food chain cannot start with plant, cannot start with animal. It's like there is a must to link back to a plant. Yeah, because food chain must start with plant. Okay, so I shall move on. So next for question number 26 over here, this is the answer. Can you check your answer? You just check whether do you have all the highlighted parts? Anyone need me to explain to you how to get part 1 or part 2? Okay, so since you got both parts wrong, okay, so I'll explain both parts. What thing? Oh, wait, this one I think the question error. This one I think they copied from the previous page. It was the chemical change. So this question just ignore lah. So this one just ignore because the question itself is question error. Cancel this question, please. Okay, so for the first part, bile, you need to know that bile is produced by the liver stored in the gallbladder. Let's write it down. Bile is produced by liver stored in gallbladder. A is gallbladder. Produce versus store. Produce means like manufacturing company, right? You keep producing. But you produce too much, then you need to store it somewhere, right? You store it in the gallbladder. So produce is liver. Liver would be B. Okay? So I label for you. Liver is B, gallbladder is A. You can label it into. Okay, I label all of it for you. Stomach. This one is the pancreas. Then this is the small intestine. Can you follow and label everything in? Label. Question 21 can write surface area, can. Okay, for paper, in a way you can still join it back by going to the manufacturing company to produce paper. Because all papers are all actually joined very long and then they cut. Yeah, so papers can be joined back at the manufacturing company, not by yourself. Okay, so I shall move on to the next part here. So they said that if you were to remove organ C, so explain why the patient experienced weight loss, because organ C is the small intestine, and small intestine release intestinal juice that has digestive juice, right? So if you have less digestive juice, you digest less. You digest less means you absorb less. That's why less nutrients. Then less nutrients for the person, then the person will become skinnier or something like eat less also lah. Yeah, you eat less also less nutrients absorbed, right? Yep, like that. So you just check your answer. Do you have these keywords? Yeah, so many is less intestinal juice, less digested food, less absorption. So if have, very good, you put a tick. If don't have, then I shall give you the answer key. You slowly go home and do correction, can? Because I don't want to hold your back so late, because already 4:45. Okay, so I shall move on. Okay, so for this question here, just now I went through. Next part. Oh, just now I forgot to go through the last. Did I go through this part? Did I go through? I forgot to go through, right, just now.
Yeah.
I go through. Okay, then let's go through it now. So this one again, same thing. Whenever got explain, remember this topic, like thermal energy or like diffusion osmosis, you always use the answering technique. So can you write down at the side? Use the osmosis answering technique. AT means answering technique. Write it down. So this one, if you haven't do it, can you just try and use the answering technique and try to write it out? Yeah, so this one you should be able to do it. Then just check the answer key. Okay? The top part definition, I think should be correct as long as you copy from the notes. So the bottom part, let's just check whether do you fill in the blank correctly. So it should be this. Yeah, so if you use my answering technique, these are the blanks. The highlighted points are the blanks that you need to fill in the answering technique. Should be done checking by now. I shall move on again. Okay, so moving on. Next, it would be the human repro topic. Yep, come check your answer. So they are asking you to describe how the hormones affect the thickness. The answer is it will cause the thickening of the lining. Yep, because you can see from day 5 to 11, it became thicker. Yep. Then this one also continue to thicken further. Then you have to follow strictly until day 22. So if you write beyond day 22, cannot. So people must read the question. So this is the way to practice to be careful in exam. Read keywords carefully until day 22. You tell me more than that, your answer is wrong. Okay, strictly until day 22.
But I'm saying like if they say like 11 and 12.
Or like 11 instead of 12, then still okay lah, can lah. Just differ by a bit, still okay. Okay, then on the next part, if the female take birth control pills to prevent the production of hormone Y, and they ask you how does this prevent pregnancy? Because if you cannot thicken, if you cannot thicken or cannot maintain the thickness, then what happens? The uterine lining will be shed off, right? And if it become too thin, then the fetus or the embryo would not be able to be implanted deeply inside. Then it might easily drop off and cause a miscarriage. Done. Yeah, so it need to be thick so that you like can grow in it. Yeah, so done for this part. Hold on, I will show the answer key soon. So just check whether you have all the keywords. As long as you have the highlighted keywords, it will be considered as correct. Okay, so I think I shall end off the lesson here then. Yep, so let me scroll to my slides. Okay, so for the lesson today, if it's possible, could y'all please help me to fill in like this feedback form so that we can know like how to better improve the session. Yeah, so can you scan it? Then I'll give you a free foolscap pad. And the foolscap is very cute one, okay? And then good quality one, okay? Ours is like the A-zone material, the thick one. Yeah. Yeah, the Avon brand. Yep, that's very cute. Yep, so once you are done filling in this survey form, you just show me from your phone, then I'll give you the foolscap pad. Okay? Yep, so appreciate your time if you can help to fill it in. Yeah, because like you see, we spend so much time preparing, right? We make the material, you see, like so take a booklet, and then we spend time to teach you during the lesson, then spend time to go and distribute to you all at MRC stations. Yeah, so could I appreciate like you spending like maybe just 1 minute of your time to help fill in this Google form? Yeah, so that we can know how to make it better. So like for last year, the students who feedback, they say that 2 hours they find that it's like too short. Like need to go through so many chapters, then they wanted longer. That's why this year we had it longer. From 2 hours, it became like 3 hours upon request. Yeah. So can y'all let us know? Yep. So once you are done, you all show it to me, then I'll distribute the foolscap pad to you. After you are done filling in the feedback form, I will show you all the answer key. Yeah, because also need to use camera to scan, also QR code. Oh, done? Okay, can. I will show in the next slide. Give me one. I show this first. So once you all are done filling in the survey form, thank you very much. Yeah, so can you all scan this? So I don't know, not scan this, sorry, say wrong. This one is just letting you know that like while I'm going through the revision, you find that wow, like you feel that you're very underprepared. So just to let you all know that OVERMUGGED is here for you for the last lab. So if you find that you need more help, yeah, we are here to be able to help you. So if you are interested in like signing up for tuition, just the last lab right before your exam, yeah, we actually have booster classes. Yep, so you can scan for more details. Okay, so then so then now let me give you all the answer key. Yep, so can you scan and make sure you save it, okay, so that you have the answers. Yep, then once you're done scanning, yep, then you can pack and go already there. So thanks everyone. Or maybe can we take like a group photo, like a selfie together? Yeah, thank you. Then yeah, then you all will be dismissed. I don't know whether can I take from here. Let me try. I think Hannah, you need to shift in a little bit. Okay, come everyone, take a photo together. Can? Oh, a bit hard to fit everyone in. Wait, the two of you, can you shift in? Shift. Maybe sorry, do you mind you shift all the way out so that you can fit them in? I cannot reach the end. Yeah, shift all the way out. Okay, thank you. Hannah, you shift in, huh? Marcus, quick, move in. Come on. Can you like lean nearer? Then everyone can dismiss. Ready? 3, 2, 1. We are more ready. 1, 2, 3. Okay, thank you everyone. Hope you all have benefited from the session and learned some tips and tricks on how to to remember some of the concepts. Yeah. Okay, I continue to distribute the foolscap pad. So if you haven't received it, you can just come forward, I'll distribute more. Yeah, so then for the online, if you have any more questions, you can click and leave already there. Yeah, so for it regarding the lesson fee for Set 4, it's the same as the previous slide over here. It's still the same. Yeah, so you can still scan and then you can let them know that you have Set 4. Yeah, okay then, so I'll end the recording then. If you have any question, you can stay back. After I distribute the foolscap pad, then I will be answering your question if you have any questions. Okay, so done. Let me stop the recording. Hold on, I need to stop the recording.